कुरु मे देव सर्वकार्येषु सर्वदा। वक्रतुण्ड महाकाय सूर्यकोटि
Good morning, all. The session is just about to start, so I would request everybody to be seated. So I just start with a brief note of welcome. So distinguished guests and esteemed experts and the delegates present here and joining online. So I welcome you all to the second day of the third meeting of the focus group on artificial intelligence in native networks. So in continuation to yesterday's technical talks, we have lined up today 4 technical talks. So I'd like to request the speakers to come and join us on the dais one by one. So first is Professor Babi Chatterjee from Triple IT Delhi. Then we have Mr. Sabir Sachi Mukhopadhyay, who is the AI lead in Tejas Networks. Then we have Mr. Kaushik Dey, who is leading the AI ML research in Ericsson. Followed by Mr. Ajay Kumar, who is scientist F in CDOT, and he's involved in AIML also. So please join us on the dais. So now, just a small point to the speakers. Because of the time crunch, I would like to request the speakers to limit themselves to 20 minutes, and it will be followed by a very short question answer session. So now I'll start with Professor Bapi Chatterjee, and he is the assistant professor of Triple IT Delhi, and his topic of presentation is predicted learning, a paradigm for machine learning native in telecommunication networks. So just a brief bio. He is assistant professor at Triple IT Delhi, and his research include distributed and federated machine learning, high performance computing, shared memory data structures, and he has co-authored or co-authored publications that are appeared at venues like ICML, AAAI, PODC, etc. And before joining Triple IT Delhi, he worked as a postdoc fellow at Institute of Science and Technology in Austria. And before that, he worked as a researcher in IBM Research Lab, and he obtained a PhD in computer science and engineering from Chalmers University, Gothenburg, Sweden. So now I request Professor Bapi Chatterjee to take up with his presentation. Thank you.
So my slides will be loaded, and will I have some pointer or something?
Yeah, should we sit that side? It will be easier for him also.
Yes,
for
yes,
us also.
yes, yes.
Is it okay if we sit there because we can see the screen?
But I think we should ask the host.
Oh, he can see us.
Yeah, right.
Oh, okay.
Yeah.
Yeah. Okay.
Sure, sure. Otherwise, I have it. Maybe I can give it. All right. So, good morning, everyone, and it's pleasure to be here. Thanks for the invitation to Team TEC, and in next maybe around 18 minutes, I'll be talking about federated learning, which I believe from the telecommunication domain, most of you are familiar with to some extent, if not maybe the entire domain. But I will try to give you some overview. So my background is more towards the engineering and the theory, the foundational aspects of this domain. So in next the few slides, of course, after giving the overview, I'll be talking about some algorithmic aspects as well as some engineering and system related things. So my work is inspired by applications, right? But I don't directly work on applications. So it will be algorithmic and engineering side of the topic. All right, so here we have the a collection of the keywords, so to say, in machine learning, right? So We all hear these words in our day-to-day sort of interaction with topics or ideas in machine learning, transformers, LLMs, and everything, right? More or less, this entire ecosystem can be sort of expressed as the following, right? So we have a model, right? So to say, maybe some kind of transformer neural network, right? Maybe SVM, the old school ones, right? And then we have training data. That model is treated with training data, so to say, right? Model is trained. Once it is trained by some process, right? A mathematical algorithm, we have a trained model, and then we use that for inference purpose, right? So our standard, let's say, hey Google kind of applications. So if you ask the practitioners, right, those who are working in industry, so if you talk with someone working in, let's say, a finance company, right, even though there are foundational models now, LLMs and everything, right, it's not that difficult to find someone who would still vouch for maybe a gradient boosting tree, right, something like XGBoost. So models are okay. There has been a lot of development in the models, right? But what exactly changes the entire game is the training data. The training data is at the core. If you ask a practitioner, it's all the game of data, right? If you have good data, if you have curated data, right, you can get almost any model work to a good extent for your purpose. So it's game of training data, right? Now, training data, of course, needs to be collected, right? Generated training data is not perhaps, going to help us much, right? So training data needs to be collected. Training data collected to data centers, that's okay. But then the collection process also involves, cases like this. So for example, OpenAI, this is like a couple of months old report published in Reuters. OpenAI was sued by someone for copyright infringement. So this is training data collection process. Sam Altman happens to be visiting Delhi exactly a couple of years ago. It was 6th June, if I remember the date correctly, 6th June 2023, when he was at Triple IT Delhi, and I was sort of hosting his fireside chat. I asked this question. And of course, around that time, there were entities even in India, NDTV and others, right, who raised this issue that OpenAI had collected data, sort of without giving them sort of credit or the whatever the required process. Okay, so this is one process of data centralization, but then there is a better way, right? So decentralized data, right? So data is available at its sources, different nodes produce data, and then maybe there could be a server which can sort of synchronize among these nodes, right? For this training data. Uh, but why even server? Server has its own problem of failure, right? Why not fully decentralized? So nodes are sort of connected with each other in a peer-to-peer manner, right? It's like a vast network. It is totally scalable. Whoever, wherever wants to join, just join one neighborhood in this entire graph. Okay, so in popular parlance these days, we call it federated data. So we have a server based model, right? And we have a totally decentralized model, but this is federated. So federated data comes along with some challenges as well, right? For example, data volume, a large amount of data, how to collect that, right? It's not perhaps immediate. Privacy laws, right? Precisely the issue that OpenAI faces from time to time, and then there are reports as such. Um, Data heterogeneity, right? So for example, different nodes may have sort of different data, so to say, let's say different collection of data. For example, some node may be generating more, let's say, when we collect the human, right? Some nodes may be generating data from African places, other places could have mixed population, things like that. So that's data heterogeneity. Unstable networks, of course, we know is perhaps the the entire research goes into sort of tackling the instability part. Untrustworthy clients, there could be some malicious players in this ecosystem, and then irregular connections and so forth, right? But at the same time, the federated data also brings opportunities along with it, right? So online data, it's like a continuous supply of data, right? It's not as if data is stagnant, that you are training your model in a 2-year old collection of training samples. Real life data, right? It will actually enable us to use, let's say, even our mobile devices to collect actual real life data. Heterogeneous data, heterogeneity brings in challenge, but it is also actually a boon, right? So the thing is that as heterogeneous as your data could be possible, as many samples you can sort of have in your data, your model is as better trained, right? So yeah. And unstoppable data, you just have your system set up, only the system can play something, but nothing else, right? And then large data, of course, dynamic data. So it also brings in challenges. Be that as it may, challenges and opportunities in federated setup. But at the end of the day, telecommunication becomes the foundation of this entire system, right? Of this entire system. So what we can do better is that, because there are challenges in collecting data, but at the same time opportunities in training the model in this vast heterogeneous data. So what we rather do is, on a network sort of setup, right? We train the model at the nodes themselves, at the data sources themselves, train it, and then synchronize the model. Data privacy laws don't allow you to collect the data. Don't collect it. Let the data be proprietary. Let it be trained on their own setup, right? The data sources setup, and then just synchronize the model. That's the idea of federated learning. I mean, in a very high, at a very high level. So please bear with me for some mathematical notations here if you are not perhaps that much okay with this part. But like I said, that I work with algorithms, so I have to sort of present something around that. So roughly, the centralized setup of machine learning can be expressed by this equation on the extreme left, right? So we have a model, and then iteratively we train the model. What is exactly training? The model gets some update in form of gradient. So that is well, I mean, without going into too many details, it's like model updates, right? Iteratively, iteration after iteration, and after a number of iterations, we say that the model is trained. That's the idea of model training in machine learning. In the middle, we have update algorithm for federated learning in a server-based setup. Idea is that this I, the superscript I on the model W, right, indicates a node or a client, right? So the first equation or first relation, so to say, in the middle portion of the slide, indicates that the model is trained locally. Okay, so model is trained, updated, locally at the client itself, ith client. And then what we do, we have a bunch of such clients participating in this tth iteration or tth round, so to say, and then we just average the model. This is the most basic idea in federated learning. One server, right? The server will have the model as W subscript T, and the clients will have model W subscript T, comma, its K superscript I. Okay. In a fully decentralized setup, there is no server. So of course, each of the clients sort of have their own neighborhood, and in the neighborhood, so as they train the model, they exchange their model state, right, with their neighbors, and then based on their neighbor, there is sort of synchronization. That's fully decentralized federated learning. Okay, so this is the core idea in terms of algorithm, right? And of course, then we are motivated by improving this algorithm in terms of, let's say, if we have unstable networks, then how to tackle that challenge. If we have, let's say, slower connection, how to tackle that challenge. If we have limited bandwidth, how to tackle that challenge, right? So synchronization, of course, is of course a total no in any kind of network. So therefore, asynchronous setup, how to tackle that challenge. So the algorithmic advancement in this domain is motivated by tackling these challenges in the network, the telecommunication network. Okay, then then very quickly there are like two sort of interesting aspects of this data distribution. So we saw that okay, there are clients, multiple clients, right, and they will have their data, but data, of course, that way becomes distributed. There are two ways of distribution of data. So a typical machine learning data, regardless of whether it is supervised or unsupervised, has multiple features, right? So here what I have done is that I have expressed, so let's say I have these many samples. So I believe there are roughly maybe 10 or some rows, and then each data sample has these features, right? So roughly maybe 16 or 18 features, for example here. So a typical distribution would be that different clients would have different samples, right? This is called horizontal partitioning of data, and consequently horizontal federated learning. Okay. The other way could be that we have each client having samples, the same samples, but the features are different. So for example, it's very typical in many setups. So for example, in Austria, where I stayed for roughly 3 years, right? Using our security card, we had sort of data with the health center and then with bank and everyone, and it was very much sort of this kind of a distribution, and they could collaborate among themselves to train some kind of a machine learning model to identify some characteristics of a client. And this is very typical in many other setups in India also. I believe these days credit card companies and banks and other such entities are collaborating among themselves, in this fashion. Okay, so the basic federated averaging algorithm I already talked about, right? This is roughly maybe 8 years old. This word, the terminology which was coined, right? 2016 around, if I remember correctly, in Google. So Google actually used this kind of machine learning model training to train their Google keyboard, right? So this is the first work which everyone cites on federated learning. It was updated a bit. In fact, people found that for heterogeneous setups, this kind of update works much better. Idea is that again, in terms of algorithm, without going into the details, idea is that we also, along with the empirical risk, so to say, in machine learning parlance, right? We also minimize the distance from the centralized model, right, or the synchronized model to the client's model. That's the idea. So this is minimization process algorithmically. So we minimize that. What exactly it does? It actually helps us in checking the client drift, the heterogeneities, tackling the heterogeneity. This is very popularly known as FedProx algorithm. Okay. So then, so then what we did, this is a new work from my lab, right? What we did, we actually generalized the ideas, right? So there are so many algorithms, in the domain of centralized machine learning training. So I have listed down here roughly 47 such combinations of different algorithms. So there are hundreds of algorithms published over, I don't know, last 60 years and so, starting from the basic algorithm called stochastic gradient descent. And then in my group, we actually combined these algorithms and then found that what exists is just surface. And so very interesting and very sort of insightful such ideas can sort of generate performance which was not seen before. And this is our experimental result, right? That we mixed some algorithms which existed before in centralized domain beyond what is now there in federated learning setting, and then we have a very impressive performance improvement. Okay, different data sets here, and along with their results, in almost every case across the benchmarks, we got very interesting results. All right. In machine learning, one more very interesting, topic is causal learning. Okay. So very quickly, maybe I will just cite one example. So what happens when you have, let's say, fuel price rise, right? Uh, Fuel price rise, it will actually affect the sort of cost to an airline company. But at the same time, airline company cannot base the ticket prices directly that often, right, with changing fuel prices, so that they will have sort of proportionate number of customers. So this kind of, so there is a cause and effect, and in machine learning you cannot perhaps learn directly based on, let's say, the outcome, the ticket cost. You cannot learn maybe what is the fuel price, right, which is just changing the cost to company. Okay, so this kind of setup is called causal learning, and it has its immense applications: finance, healthcare. Let's say you apply, you use some drug, how that drug exactly affects your body, right? Or there are some comorbidities which actually results into death, other things like that, right? So this causal learning played a good role. Okay, so then in causal learning setup also we sort of implemented that in federated learning setting, and then we have very encouraging result. Again, this is a very new work in my lab. Okay, perhaps the first work, to the best of our knowledge, for instrumental variable analysis in federated setup. Okay. Federated trustworthy learning. Like I said, that there could be malicious players which can sort of send updates which can destabilize the system. So for that, you need provenance of the updates, right? You need to track how the updates happened, right, over the system. So as we know that blockchain played its own role, starting from the power, the same seminal, so to say, right, the Bitcoin network, right, and then blockchain is applied to supply chain in all sorts of setup, which it was. I mean, blockchain at this point is for NFT and other popular coins and so forth. Maybe at some point we encounter blockchain based applications. So in federated learning, again, blockchain helps us in keeping provenance of the records. Again, this is a work ongoing in my lab, right? So where every update we record on a blockchain. It gives us trustworthy federated learning. All right. Then, like I said, that telecommunication networks have their own challenges with bandwidth and everything. So we need to also be mindful about which data we should select. It should not be that if we have collection of 1 trillion tokens, then all the tokens have perhaps equal effect in machine learning model training, right? So therefore, we select some data without compromising the accuracy of the model. This is called core set, right? Core set of the training set. So we implemented that in federated setup. In fact, vertical federated learning setup. And this is a paper that is going to appear in this prestigious conference ICML this year. Okay, so I will sort of end my presentation by giving you an overview of what we are doing in my lab at IIIT Delhi. So we are working on a scalable framework for federated learning, where real-time machine learning model training could happen. Right, this framework can be applied for spam filters, for example, in telecommunication setup. Consortium of diagnostic centers can use our framework to perhaps train machine learning model on their data, which they otherwise cannot exchange, right? Real-time agriculture data in rural setup, this framework can be used, right? Then financial model training with private data, you cannot exchange such data, right? And then real-time machine learning model training for policing, even that could be a potential application for our framework. And then decentralized LLM training. Avoid the mistakes that OpenAI and others are doing at this point. It has to happen, as people predict, right, that decentralization is the way to go. So, yeah, that's roughly my work in the lab. And with that, I invite any question if you have. Thank you.
Why federated data is divided horizontally and vertically? What is the difference? What is the advantage of both?
Okay, sure. So horizontally is natural. You have your, let's say, so Google keyboard, right? As we know that these days Google keyboard is very efficient, right? It has used data in terms of the sentences that we type, right? Over a period of several years. But that is proprietary. The sentence that you type is your own property. Google is not supposed to sort of collect that, right? So so that way, it has to have like collection of data over different clients. That's horizontal partitioning. Like I said, that samples are partitioned horizontally. The other one is vertical partitioning, where the features, maybe let's say the same person, you as a person, is recorded with the government of India by Aadhaar, right? Now let's say you have your health records, you have your financial records, you have your other sorts of interests, right, recorded somewhere else. So person in terms of sort of forming a sample remains the same, right? But the different features of your character of, let's say, your sample in that training data can be partitioned. They can, so for example, bank is not supposed to exchange your data with some gaming company, but they together can train a model. So that's the vertical partitioning. That's the difference. Okay, and both of them have their own applications. Sure. Vishnu?
Yeah, first of all, thank you very much, Bapi, for coming, taking the time. It has been a great collaboration from your team.
Thank you.
We have talked to Raghav was here, Ranjita was here last time, and you are here. Thank you very much. I think mine is not a question, it's just a comment that your work is very important for us. This focus group looks at AI native technologies, and one of the core enablers for us is federated learning. So it allows us to put the machine learning and AI in different parts of the network. It allows us to do the training in different parts, including the edge and the devices. So this is why it is really important. The cost aspect, in terms of data, core set, especially the core set aspect, we have discussed previously also. The core set aspect is very important for us. It allows us to reduce the data cost,
Yes.
not the dollar cost, but
Yes.
the data cost
Yes.
of this federated learning, especially in the context of AI native. I think that's very good, and let's continue. Thank you very much.
Glad to know. Thanks. Thank you.
Thank you, Professor Bapi, for your insightful presentation. So now I would like to invite Mr. Sabyasachi Mukhopadhyay, AI Lead Tejas Network. So I'll give a very short bio. So he has 28 years of experience in the AI ML field, and he has built multiple scalable AI platforms for different telecom companies, and he has experience in like Ericsson and in Juniper Networks, Cisco, Lucent, HFCL, and very interesting, he is currently pursuing a PhD in generative AI from IIT Hyderabad currently. So his topic of presentation is foundational AI models in telecom systems. So now I would like to invite Sabyasachi Mukhopadhyay.
Hi. Hello. Good morning. It is a pleasure to speak in this forum. So my name is Sabyasachi. I lead the AI activities in Tejas Networks. Tejas Networks is a global telecommunication vendor dealing with equipments in routing, switching, optical, wireless, GPON, and I lead the AI team there. So my topic is foundation models in telecom systems. So I'll start. So basically, what is a foundation model? So if you see, the foundation model was, the term was coined by the Stanford University of Human Sciences, and basically it means that is a machine learning model which is trained on a huge or large amount of data, and it is a very large model and it contains millions of parameters, and the model also can be fine-tuned to the scenario, to any scenario, for better results. So why do we need foundation models? The reason is, in previously always in the typical previous machine learning scenarios or parlances, we used to have to train separate models on various data sets. And that used to take a lot of time and a huge infrastructure to train the model, and it could not be adapted to various domains or workloads seamlessly. For example, suppose in case of our telecom system, suppose you have multiple ports and data is coming from multiple ports to the system. Suppose you want to do forecasting for different ports. So you used to have different models to train the model on different ports with the training data, and it used to take a lot of time. So with these foundation models, the key features are that it can understand broad patterns from massive data sets. It is trained without explicit labels, and it can be easily fine-tuned for specialized tasks, and it offers very good zero-shot or few-shot capabilities. So this is a general flow for foundation models. So basically the foundation models, this is sort of a usage chart. So first there is the input data, and then there is a pre-training with various techniques, and we have a pre-trained model. And with that pre-trained foundation models, we can do either a sort of a zero shot, or we can do a few shot. Zero shot means basically you just place the model as it is, feed the data with the context, it will get a result. Or you can do a few shot, you give a few examples to the model of a particular task, and it will actually forecast, or it will give a result as per the task, or you can fine tune the model as per your specific needs. So as per the industry standards, mostly we currently use zero shot or few shot. Fine tuning on very specialized cases we use the fine tune. So the applications. So in case of the applications, the foundation models can be used in a diverse set of applications. For example, it can be used in natural language processing, in chatbot, summarization, translation. In computer vision, we can do segmentation. In multimodal AI, in predictive analytics, foundation models are playing a key role now. In healthcare, in robotics, automation, creative and generative AI, recommendation systems, across all the domains, the foundation models are playing a very important role. So I will just go over a few applications which we are doing in Tejas networks, typically in the NLP as well as the time series domain, and also we have started some vision related activities now. Now, in the NLP side, we have the chatbot, which is actually talking with a host of agents, and they have several tasks here. We have document search, we have RCA assist, config assist, defect search. So what are the activities here? For example, in the chatbot, suppose you give the information to the agentic systems which are running on foundation models. You can do a config assist. That means if you give an intent, you can you can generate a config from the intent using the foundation models, either in the zero shot mode or in the few shot mode. Again, you can do a defect search. So defect search, basically, you have your defect repository, and if you give a sort of an intent or a sort of a trouble statement, you can have a rack system which will have the defect repository. You can give the trouble statement. It can search the defect repository, actually orchestrated as a rack system, and then the output can be passed to a foundation model which can synthesize the output, summarize it, and present it as with the summarization of the defect which is existing. You can do a document search. For example, suppose you have a document repository, you can feed it as a rack system. Rack means retrieval augmented generation. So basically the document can be chunked, vectorized, put into the rack database. You give a document search, it will pull up from the document as a context from the rack system. It will present to the foundation model. The foundation model with the context and the actual query will give you an output, a synthesized, summarized output. This is the use case. In RCA assist, we can actually use a sort of a graph-based system which can be tied up to the foundation model, and we can get a sort of a analysis of the defects which are currently there, of the root cause of the particular alleviation, any other mechanisms we can use the foundation models. So these are the various use cases we are using the foundation models. As I told, RCA, configuration assistant, generation of configuration, zero shot, few shot, and then defect assistant, finding the defects, duplicate defect reduction, this sort of use cases. Now, a very interesting field is in the foundation models in the forecasting. So previously, when we started the forecasting activity, we always used to use data-dependent models, like for example, LSTMs, or some other models like ARIMA, SARIMA, Prophet, data-dependent models. So what used to happen is that we used to have a data set for a particular system, for example, port, or for example, any other particular system, and we used to train the model. The training used to take long time. LSTMs typically, I remember, I used to train for about like 1 hour, 1.5 hours with huge data sets. And that model is to change for various different ports what we have in the system for doing a forecasting. And also the forecasting horizon is to be limited. So for example, at the best with LSTM, I used to have like 3 hours, 4 hours, like sort of forecasting. Now with these foundation models in play, we can use a off-the-shelf model, and then we can feed the context to the model, and it can do a long horizon forecasting. For example, we can do a seven days, 2 months, 3 months forecasting with a context. So some few models which are important, which are coming up as foundation models in forecasting. These are open source models. First one is the closed source, TimeGPT. So these models, they're available off the shelf, and you can actually use those models, give a context, and do a long horizon forecasting on them. For example, TimeGPT is a model which is developed by Nixla. It is a closed source model, but it has a transformer architecture, and it is basically, it understands the order of past events. It is trained over 100 billion data points with various different time data sets of finance, healthcare, weather, IoT. And TimeGPT, it can make very accurate forecast. It has a very long horizon. So I have actually made like 3 to 4 months of forecasting, advanced forecasting with TimeGPT. It also has multivariate capabilities. You can add exogenous variables in order to fine tune the forecasting better. It also has advanced anomaly detection capabilities. Time MOE is a mixture of experts model. So basically, this foundation model, sometimes it has huge, sometimes the size is big, like suppose 1 GB, 2 GB size, and it takes computational resources. In case of this MOE model, basically there is an array of experts and a few experts can be used to do the forecasting based upon some routing mechanism, and the computational resources shrink. So time MOE is a mixture of experts model. Moirai is a model which has come from Salesforce. So Moirai model, the main capabilities of the model, it is a very good exogenous, inherent native exogenous capabilities. And Moirai is also encoder only model. It is a probabilistic model. And for example, it gives the forecast for 100 samples. You can do a median of that and get a point forecast. And it supports exogenous, and it uses a mixture distribution, and then it has also developed a LOTSA dataset. LOTSA dataset is actually a dataset which is having data from various different 9 foundational models, different domains in time series with a various granularity like seconds, months, years. It has that data set. And then TimesFM. TimesFM is a model which has come from Google. So TimesFM is a point forecasting model, and it is very accurate. It can do a long horizon. It has a restriction of the context. It has 2,400 context points, but it is a decoder-only model, and it can predict longer future sequences in fewer steps. Now, as I told, what is the application? So, for example, we have this foundation model, and we have various domains. We have routing switching, we have manufacturing, we have wireless, GPON, DWDM. So on these various domains, we have various applications which are actually based upon the forecaster, like energy saving in wireless. We have resource optimization. We have resource optimization, failure prediction in manufacturing, capacity planning in GPON. We have power profiling, capacity planning in DWDM, anomaly detection. All these various domains, you can have a single foundation time forecasting model. You can feed the context of the particular data set, and it will forecast the horizon you want to. The configuration is extremely simple, and there is no training mechanisms involved at the back end. Suppose you do want to use the model for a specific particular data set which is very peculiar, then there is a capability of fine-tuning the model. You need not train the model as the LSTMs we used to do for half an hour, complete all the layers of the model. You can specify a few layers, and it will take hardly, let's suppose, few seconds to fine-tune the model. In general, the forecasting takes a time period of 1 second to milliseconds. So it is very fast, very efficient foundation models in this forecasting area. I will present some sort of results what we have for GPON and also wireless. So for the GPON, we have the use cases as capacity planning, resource allocation, quality of service, cost savings, enhanced decision making. for example, this is the GPON RX octets. So what we have done is we have done a weekly forecast with a 1 hour time granularity. Like for example, we have 168 data points. We are forecasting in advance. And if you see, the accuracy is 85.6% of the weekly forecast. And it all fits within the CI boundary. And the red is the predicted, the blue is the actual. So if you see the pattern, it fairly understands the pattern and is able to do a long horizon forecast. And similarly, on the wireless, we have done a forecasting. We have done the forecasting for this RRC connection attempts, accuracy of 93.96%. It is also fairly accurate. If you see the pattern, the predicted and the actual, it is almost tallying. We also did a sort of a forecasting for a month. We are currently trying 1, 2 months, 3 months forecasting with these foundation models. You can understand the advantage, right? Now, there is also, we are recently embarking on the activity of using the foundation models in image processing. So in the image processing, there are some models which have been come out from Meta. The models are SAM and SAM2. So SAM is actually trained on SA1B data set, 1 million masks. We are trying to find out the masks from this data set. SAM mostly static vision elements, and it is a general purpose segmentation models. SAM2 is sort of a advance on that. So SAM2 basically we can actually segment the video, and the SAM2, the advantage is it is a foundation model, and the advantage is like if you can mask a particular frame, you can divide the video into multiple frames. If you can mask a frame, it can actually repeat across multiple frames and do a video sort of segmentation. So this is the foundation models in image processing, and these are the sort of use cases. So with this image processing application, we can do predictive beam and blockage management. We can identify the blockages in the beams with this segmentation. We can do a localization of the receiver. We can detect the object, do the localization of the receiver. We can do an environmental aware channel estimation. And we can also, the major activity what we are doing is that in the wireless systems, it is sometimes difficult to do processing on the actual system. So what we are doing is we are doing a digital twin where we actually do a simulated systems, and on that we use the SAM model to generate identify the various objects by segmentation. So I would like also to go through a few this thing. So with respect to model size and the model time, so a few models, what we have actually tried several foundation models with respect to forecasting and data dependent models. So for example, first the time GPT. The time GPT, the main thing is it is an API based model, so you need an API to connect to the system. And the typical inference time, as I told, it is very fast, 3 seconds of inference time. TimesFM is the Google model, so the inference time is like 7 seconds. It is a bigger model, and TimesFM, there are 2 flavors, 200 million parameters. It is size is 814 MB, and TimesFM2 is the newer model, 500 million parameters. The size is 2 GB. The Moirai model from Salesforce, the inference time is 1 second, and the Moirai large size is 1.24 GB. So the model is a little bit bigger in size, but as you can understand, you don't need to actually replicate the model on your thousands or millions of ports what you have and do the forecasting. One model is there. You can do a zero shot. You can have a context. You can do the forecasting on the model. Similarly, on the SAM side also, if you can see, the sizes are in the order of MBs, but the inference time is pretty fast. So yeah, so that is more or less my lecture. So I would ask for any questions.
Good morning, and thank you for a very insightful lecture. So just I was wondering whether this foundational model which you have just introduced to us, uh, how much explainable it is, or how can we compare it to physics informed AI models, which is
So,
talk.
so these transformer-based models are sometimes black box models. So the explainability is sometimes less, but you can always tie it with external tools, which can actually help in the explainability. There are external tools which can be used in the explainability. But in general, the time series, from the time series perspective, uh, if you say the time series model, what we normally do is the accuracy with respect to the MAPE scores. So what we check is the actual versus forecasted and the accuracy. So from that metrics perspective, it is pretty good. If you want the explainability additionally, you have to add some extra tools to it and do the explainability. The transform models are typically black box models.
Okay, and then has it got attention of means economics? Is it getting used in economics for understanding the short run and long run dynamics among the time series models? Means
It can be used across any domains. So
Okay.
you give it a time series, it will do the forecasting. Any domains, any horizon, it can be doing the forecasting.
Okay,
So it
great.
is domain independent. That is the main beauty of it.
Thank you, sir.
Excuse. I have a question regarding wireless actually. What I can see, the model is there for forecasting something, say for RRC, this connection attempt plot, something.
Right, right.
So are you planning to use the models or like any other model for optimizing the RAN network also? Or you have any plan for RAN network to
Yeah,
be deployed
so
in the field?
Yeah, in the RAN network, there are various applications, right? So in the RAN network, for example, let's say energy saving or layer optimization or different applications are there, use cases are there. Each of these use cases has forecasting as sort of a basic pillar element. So the elements from the forecasting will feed into these use cases and these use cases which use the forecasting results to actually implement them. For example, let's say the use case of energy saving. So energy saving, what it does is you try to save the energy by checking how much load is there on the system. So if the forecasted load is going below a particular threshold, you try to switch off the system or transfer the load to some other systems. So the basic pillar of the system is forecasting. So if your forecasting is very good, your energy saving application also will be good. So in RAN, several such applications or use cases essentially use this forecasting as a basic pivotal element. So if you have good forecasting results, automatically all these applications will also come through.
Yeah, excuse me. My question is basic one. Say whatever forecasting models you named, are they not using the old mathematical our understanding like scattering or linear regressions or something to forecast a time series in the background? This mathematics involved. That's what how the data earlier also used to be forecasted actually, isn't
It
it?
is a little bit different, I would say. It is not exactly the classical mathematical abstractions what we had. So it is more or less, it is derived from the language-based translation or language-based foundation or the large language models what we have. So language, what is language? Language is nothing but a series of words, and the future of the words, when you do a sort of a generative AI on the language, the future of the word depends upon the past words, the context. Now in the time series also, when you do the forecasting actually depends upon the inherent interdependencies of the time which elements which are there in the past. So these models are actually transformer based models. You feed the time series to the models, you tokenize the time series, you've embedded them, then you feed them into an encoder or decoder model which actually generates the forecast outside. So all these foundational models are mostly transformer based architecture.
So again, but the data or the type of data or whatever precedent data,
Huh, huh.
so it is analyzing in some way in the same fashion to predict the
It
the
is-
next word or next
it is-
course or something, isn't it?
It is
so
there.
some mathematics, as earlier Professor Bapi also said, in the mathematics, whatever gradient, say feedback mechanism or something like that, and isn't it? So just wanted to have your-
for the training or pre-training or actually devising these foundation models, you need to have a loss element like MAPES code. You feed it to the transformer elements. It goes into cycle. It generates the model as a MAPES code, and the model comes out. But it is essentially different from the statistical models what we used to have earlier, the ARIMA-SARIMA models.
When you see the models for different applications, the accuracy is varying very big change. How do you set the benchmarking those accuracies of that models are concerned?
That is a good question. So for benchmarking the accuracies, we typically use a baseline model, or we use a sort of a naive systems. For example, it can be a seasonal naive. So you take the seasonal parameters, whatever seasonal values was there earlier, you replicate it, and you prepare a baseline system. There are several seasonal baselining systems actually. So you prepare a baseline systems either through the naive methods or through statistical models, and then you check your model how it is performance with respect to the baseline systems.
Sir, forecasting model normally works, but if suppose there is a event, forthcoming event, and if you see the data of the previous month even, so it's all later, there is no much gradient. So data is almost similar. So forecast will be as per the past data, but tomorrow there is an event. So in that case, forecast will be wrong.
So this is also a good question. So these models, they have inherent capability of capturing or taking the events into consideration while doing the forecasting. So you can add historical or future events which you have unknown as an exogenous variable to the model to do the forecasting. So the forecasting becomes accurate.
Period of data to be used to have a forecast should be of bigger period, like year or 2 years or like that.
It can be done. It can
Should
be done. Depending upon the aggregation and other things, you can use a large amount of context.
Yes.
Okay, thanks.
Thank you for a very good presentation, sir. So I'd next like to invite Mr. Kaushik Dey, who is heading the AI/ML research within Ericsson. So brief bio. So he heads the AI/ML research within Ericsson and also leads the 6G for India research program, which aims to incubate the 6G according to needs of the nation. And he has almost 2 decades of experience in Ericsson and IBM across various functions like AI research, product development, and lead realization of key research paper around zero-touch network, adaptive multi-agent frameworks, domain generalization, ultra-low energy AI, etc. And his personal interest is in the field of reinforcement learning, autonomous agents, and agentic frameworks. And he has holds 25 international patents. And he's also a PhD degree in computer science from IIT Kharagpur. Thank you. I'll now invite Mr. Kaushik Dey for his presentation.
Thank you. So thanks for this opportunity to present in this August forum. So I think the previous session, what we had, it kind of leads very nicely into this. So we were talking about generative AI and transformers. So nowadays, what you hear a lot is about agentic AI. You know, you hear about agentic AI, MCP. Nowadays, it's about A2A, Google framework. So all these are what it's dealing with AI agents. What is an AI agent? AI agent, we could think about it's a manifestation of, say, a human capability. It could be in a physical form, it may not be in physical form. So if you have a robot, you know, kind of walking up, serving you a glass of water, it is an AI agent, a physical manifestation of AI agent. If you have AI agent, or say an automated function which is trying to understand where you want to go, what places you want to visit, and then making a complete booking and itinerary for you, that is an AI agent. Similarly, in networks also, there is a huge importance of AI agents. This is still an evolving field. So while I present this, there would be some hypothesis around where we might be going in future. But at the same time, the network presents some unique challenges. It has its unique characteristics. The overall complexity of the network is multifold. You have the BSS, the OSS, the core, the transport, the RAN. The RAN, within RAN itself, you have L1, L2, L3, and within L2, you have probably 10 different functions which you need to optimize. So how does AI agents, fit in the context of network? I will probably try to speak around that part. So before I go there, let us look at how we are evolving as a network. What we were probably around in the stage of manual operations. From there, we can claim that most of the network operators have moved to automated execution. What automated execution in itself means is that we know the task which we have to execute, and then how the task would be executed, that is done by an algorithm. But the task itself is chosen by a human being. From there, what we are going towards is what we call as an intent-based operation. So it's an intent in a sense that we want a network to achieve some high-level tasks, some high-level goals or objectives. How those objectives are translated into the desired KPI goals for each layer, be it the core or the RAN or within RAN each layer, is something that needs to be autonomous. And once it is autonomously selected, then there are algorithms which are also autonomously selected in order to execute that. In order to implement this framework, the agents become very, very important. And while there has been a lot of literature around AI agents, agentic AI over the last 1 year, let me tell you that this is not new. The entire LLM paradigm has kind of made this agent word mainstream, which is good, but it was there previously also existing. And probably even in many circumstances, and particularly true in the networks, what we find is that there are different other techniques which could be more suitable for implementing AI agents. When I say that, I mean, as I slowly describe this, remember one slide which Sabyasachi showed. He was showing a latency of, I think, among all the different models he showed a minimum latency of 1 second. Let us make it a little bit more, futuristic. Let's say the advances in GPU, with the advances in quantization, let's reduce it to 500 milliseconds. Okay, and then we will see where the problem is. Even after we make it better. So now, what we are saying, we are trying to move to a phase of adaptive autonomy. So adaptive autonomy means, given a broader expectation, the network will figure out how to decompose that intent, how to allocate the intent across the various domains of the network, how to orchestrate the different objectives across the network. So imagine you have a simple, like a big kitchen, right? There are somebody cutting a onion, somebody, doing something with the chicken, somebody doing something with mixing a dough or something. All this needs to be coordinated when you are making a pizza. It cannot be that somebody has, chopped off a huge peel of like onions and then the dough is not prepared. The onions will get stale. So there needs to be a coordination. Easier said than done with a pizza example, but it is probably a million times tougher when you are trying to coordinate how you optimize or how you orchestrate a scheduling in a L2 with respect to how you will set the packet priority in your air interface. So how can that be done? So with that, I mean, intent, I think Professor Chatterjee was also alluding to it, that what is an intent. So intent is an kind of an elaboration of an expectation, a formal specification of an expectation. It could be something like, for the web users or for the URLC users, I want a latency which is less than, say, 20 milliseconds, and I want a packet error rate below a certain limit. So it could be an expectation. Now there could be various intents in the system. So where we are heading towards what we call as an intent management framework, which will manage these different intents, which will coordinate, orchestrate, and optimize the system such that these intents can be fulfilled. This coordination or orchestration optimization has to work across, again, all the layers. So having said that, how does this kind of manifest these intent management functions across various layers? This is a hypothetical example, extremely simplified for the purpose of this broader presentation, broader discussion. So please do not take it literally. So okay, we have the system intent coming in here. Then we have, say for example, what we need to do an intent decomposition. The intent decomposition happens at a higher layer. What would be the kind of objective you will allocate to radio or the RAN? What is the kind of objective you allocate to core? Again, in a simplified way, there are many more parts to it. Then once you have allocated an intent to radio, say for example, you have the L1, L2, and L3. What is the kind of a, say, a latency that you want to achieve in the scheduler? What is the kind of power control you want to do in uplink? What is the link? How will you do the link adaptation? What is the admission control that you will do in RAN? So these are the challenges that you have in RAN domain. So here, naturally, what you could presume that how about having a reasoning agent which can break up the overall goals at the RAN layer into these different components. These different objectives or sub-objectives. And then when you break it down, you could say, I will have different agents fulfill the same, right? Fair enough. Then you have another, say, the core network. Similarly, you could have a reasoning agent and then breaking it down, and then you could have different agents fulfilling the tasks. There is a slight difference, or a significant difference rather, between core and RAN, as we all know. But one of the things I want to point out is the latency. So if we look at the schedulers, the schedulers typically need to operate at less than 10 milliseconds of latency, and some of our researchers would vehemently disagree with me. They would say that it is less than 1 millisecond of latency. So, but okay, if we take 10 milliseconds, let's be liberal and take 10 milliseconds, then how do you push an algorithm which has a latency of 500 milliseconds? Can you? So that there comes one challenge. Secondly, the compute availability. In order to do an inference at the edge, you need a significant compute. What is the kind of compute? What is the kind of compute we have in base stations today? The AI compute? Any guesses? The answer is 0. We don't have any kind of AI compute in base stations today. Tomorrow we will have, definitely, in 6G. But the thing is that even when we have compute at the edge, there are two challenges. There is a challenge of memory and again the challenge of latency. So what is the kind of, when you push an LLM, to process all those tokens, even if it is 2000 tokens, do we have the kind of memory? We don't even have, or will we have the kind of memory in the first generation of processors which are going to be incorporated? Probably we will not have even 10 or 20% of that memory. That's the second challenge. Then I don't see it as a challenge, but it's kind of a challenge and a solution. So in view of all these challenges, probably we need to recognize that our systems, the entire network is significantly different from the agentic architecture, what say probably a travel booking site, or say for example some other business processing site which it could have, where it connects one LLM to another LLM, another LLM to another agent using a lang chain like structure. That may not work. So rather what might work is a more heterogeneous structure where we have different kind of ML agents. Along with, there could be an LLM agents in some cases where it is suitable. And there could be some classical rule-based agents also. It's very unfashionable to say, and particularly for me as an AI researcher, but I must admit the kind of latency which today, even simple rule-based algorithms can achieve for extreme low latency control loops is not something that AI as of now can achieve that. So for simplistic, more deterministic functions, I would rather go for a rule-based setup, kind of encapsulate them as an agent. So now, what we have these different kind of agents. Let's presume we don't have it now. Let's presume we have these different kind of agents, from reinforcement learning to some prediction agents to classical rule-based agents, and all this needs to work in a framework, right? I mean, they cannot operate independently. So there can be some kind of a coordination framework. And then looking to another paths, what we could also do, which is probably possible now in some instances we have done it, is using a combination of RL agents. So sorry for the clicker. So so what we could also do is we could look at the entire technique of reinforcement learning, and we could have multiple RL agents coordinating different optimizations in the network. So there could be one RL agent optimizing a packet priority. There could be another RL agent optimizing, say, a bit rate. And then recall, there are multiple intents. You are not dealing with only one intent in the system. So for all those different intents, there could be multiple such RL agents. As you have multiple such RL agents, these RL agents need to coordinate with each other. So how they coordinate is, one of the ways is what we call as a multi-agent RL framework. Imagine the multi-agent RL framework as a kind of a football game, where individual footballers, say, imagine they're kind of robots, where individual footballers have been taught how to play using reinforcement learning. But if they don't learn to coordinate, you can understand what would be the result. So now using multi-agent RL, we have taught them to coordinate. There are various aspects of multi-agent RL which we do not have the time to go into with respect to whether agents can communicate with each other or whether agents cannot. If the agents cannot communicate with each other, it imposes a restriction, but the advantage is I reduce the overall communication overhead. But we have a few MARL agents, we have prediction agent, and then we have a framework which controls this MARL agent. This framework, which we call as a reasoning agent here, this can kind of orchestrate. And how this will orchestrate is something that we are showing in a demonstration here. There can be various ways of orchestration. We are orchestrating this through a reasoning technique called the AHT. And above this, we have more like a reasoner or a planner agent, which is looking at the different high-level intents. It is breaking it down into RAN and core intents. I think in the demonstration, what we show is only for in the RAN, only for the scheduler. But of course, the RAN is much more broader. Slightly smaller fonts here. Apologies if you can't read it, but this is the next level. I mean, kind of peeling the problem for the next level. So what we have now is an intent decomposition. Then say we have multiple intents. One is URLC, then is MIOT, and say for example some conversational video. there are various KPIs. Say, for example, in core, you have a packet loss, latency KPI. Another, for MIOT also, you have packet loss, and then you have QoE. To control the packet loss, you could modify the packet priority, or you could modify also the bit rate. But these two agents need to be in sync. Now, this yellow agent also needs to be in sync with the agent which is controlling the packet priority for the MIOT, right? Otherwise, if you increase the packet priority for URLC, you will implicitly decrease it for MIOT, even if you do not do anything. So these two needs to be in sync. How will they be in sync? Let's ignore the latency for simplicity. That is to multi-agent reinforcement learning. I will skip this in the interest of time, that how it works. But essentially then, what we have is, we have agents for all these different intents, which are working in conjunction. They're taking action on the network environment, and then they're measuring the KPI. They're seeing that how far they are from their intent, how far they are from the goal, and then they're again kind of doing the next round of optimization. Here the critical thing is that agents are both selfish, at the same time they are tuned to for a team game. So they have their own objective, and at the same time they have a global objective which they have to meet. How that is, so this entire framework, if you look at it, so these yellow agents, these form a group what we call as a multi-agent RL group coordinating packet priority. These orange agents form a group which we call as a multi-agent group for maximum bit rate. And then while these three collaborate among each other, these three also collaborate among each other, but overall it is collaborated by another reasoner agent. So because their tasks are now divided. And this division of tasks and then solving the problem, it goes on at each layer of network. So if you look from bottoms up, it's starting at a basic level, then it's aggregated, then finally it's meeting its goal. So this is a I did not get into the mathematical details of multi-agent reinforcement learning, but there are two other aspects after which I will like to end. One is the need for flexibility and adaptability to real world application. I think, gentlemen, I think you were asking the question of what happens if that data is not there in the last month. If I see a new data, that's something that happens often, right? We human beings, we are trained to adjust to new situations based on intuition. So how can we ingrain that intuition into the AI algorithm is something we call as a generalizability. Now, where are we with respect to generalizability of AI algorithms? We are still at basic level, because our algorithms can only perform according to the data which has been shown to them. New data distributions which they are not aware of, that's something we call generalize. We have limited capability to do that. Now, having said that, okay, there is another challenge. What happens when the resources are scarce? All this, resource sharing works very well when the resources are enough. But resources are never enough, right? So what happens? So at that time, my entire system should be able to understand which is a high priority application. That priority might be given by the human being, or it could be supplied by the system. And accordingly, these agents must learn, autonomous agent must learn how to trade off. That, okay, I will give up my resources so that another agent can consume it. That will enable a critical service to meet its KPI. So this is something the system must have, and there is a way also of implementing it using techniques like multi-agent. Now, what happens when the environment changes? This is the generalizability. There has been some progress with respect to generalizability. So I think in the demo also we are showing that what that sum means. However, achieving full-scale generalizability is still probably a number of years ahead. There is a lot of debate on what that number of years is. Some say it is 5, some say it is 20. But when we achieve the AGI, we have kind of made the agents as intelligent as human beings. So in nutshell, what I would say is that even though, first of all, LLMs or transformers will become also important in networks, but their applicability has to be rightly chosen. The network will consist of an heterogeneous agentic structure, in my view, rather than a fully, like an all LLM kind of structure. That may not work in the network. At a time when multiple LLMs, if you operate, it will give rise to non-stationarity, which is probably possible for today an RL agent to handle, but the advancement of the capability of LLMs to handle non-stationarity is limited. Non-stationarity means I am doing something, another guy is doing something, he doesn't know what I will be doing, so it introduces an element of uncertainty. Finally, we must be aware about the challenges in the network with respect to compute and inference when selecting the right kind of agents. And then probably the heterogeneous structure is something that works best for our networks. So having said that, I want to thank you for this opportunity to present. It may be a rushed presentation, but hopefully some views have been conveyed. Please,
Kaushik Dey, sir, here.
Sorry. Yes.
Have you identified some standardization gap in it? Means use of agents will definitely require interoperability protocols, and it may have some interoperability issues.
Yeah, I will supplement this question actually. Are you thinking of having any benchmarking framework for these Gen AI models to be used in telecommunication networks?
First of all, we are still evaluating where Gen AI frameworks can be used. It can be used in higher layers, but in the lower layers, whether Gen AI framework can be used or not, this itself is a question. So we are not at a point where we can, profess that yes, a Gen AI framework will be used. So the question of putting it in standardization will come later, at a later point, after we have used it. We as of now, we just know the constraints which it has. With respect to other models, there could be some standardization implications also, but many of this work could also be in the proprietary space with respect to how it implements a certain functionality. So it's not so much about how you kind of shared the data between two vendors. It's more about, given a certain vendor system, it will have its own intent. There is a lot of standardization work around intent, so that's what will happen in a separate context. But once you have the intent for the system, how will you optimize the intent in a situation where there could be conflicting intents, in a situation where if you manage the intents using agents, there could be non-stationarity. So how do you deal with it? Also considering that you have the latency requirement of milliseconds in which you have to satisfy it.
I would like to add for this standardization. Actually, we
Sorry,
have,
yeah,
myself,
please.
yes, VK Roy. Actually, we have standard I2T Y.3172. So from intent, orchestration and management, everything is there, underlay network, overlay network, sandbox, everything is there. Actually, erection and all, if we go for the adoption of that standard, I think it's not a difficult task. So rather, we should go for that.
Absolutely.
And
I
India
agree
has contributed much in those standards. Okay, so I think a standard is possible. Beside this, my question is the final target is the autonomous adaptive network. Okay, and that multi-RL.
Yeah, I'll just respond to your first comment. So, of course, I mean, standardization in intents is ongoing. This needs to happen, and we are also supporting it in a big way. So, with respect to agents, my point of view was this is more on the proprietary work. So, standardization is possible, but may not be needed in all circumstances.
Step by step, proprietary.
Yeah, I mean,
it is not possible at all. There is no question. But where some common things where we can have this thing
Right,
for
of course.
transparency.
So we have to identify what the
Yes,
common
yes,
objectives.
So
Yeah, please, your
coordination
second
is
question.
required for that. And in final, I think final aim is to have adaptive autonomous network.
Exactly.
Okay. So in multi-agent RL coordination, orchestration and management, the challenge is for all agents have self and global goal. So I think the conflict resolution is the most important thing. So how do you think that this is going to be done and this is being done? I think
Okay,
conflict
so
resolution.
I will probably go a little bit technical, at this point to answer the, yeah. So what you have is, or let me explain through an example. Let's say a football game, right? Now, if a center player in the center of the field, he is rushing towards the opponent goal, you also need the left flank and the right flank to also go forward, right? Now, this is not told, right? When the guy is running with the ball, the center forward, he doesn't shout to the left and the right half that you also run. How it happens is they're pre-coordinated. So they have played many games like this. The coach has trained them that when this guy runs forward, you also have to run forward. That is one way. This is what, and this epitomizes what we call as a centralized training and decentralized execution. In a centralized training in a lab setting, we give, since it's a lab setting, we can give a total observability to all the agents with respect to their how each of the action is contributing towards fulfillment of a global goal. Now, what that helps to set a kind of a coordination mechanism where in the production, in live networks, they need not communicate with each other, but since they're trained to communicate, they will act in a way which is cohesive. So that is one centralized quad. There is another thing which is called, centralized training or centralized execution. The centralized execution is slightly easier, where agents could be conditioned on another agent's behavior, another agent's action. The challenge with that is if you have n agents, then you have, the amount of communication that you need to do, it increases exponentially. So we try to avoid that for network. There are some circumstances where that could be more effective, but generally centralized training CTDE framework are more effective. And in terms of handling such conflicts and in terms of at the same time doing the coordination.
Yeah, thank you so much.
yeah,
Can we take
Amit.
questions during break? We have one more presentation to go, actually.
Okay.
Yeah. Yeah, thank you so much.
Thank you. Thanks.
Thank you, sir, for the presentation. Now I would like to invite Mr. Ajay Kumar, scientist at CDOT, for a presentation. And short bio, he has been working in the field of AI ML for 25 years, and he has developed intelligent systems that learn and adapt from the data. And he has expertise in deep learning, computer vision, and NLP. So now I'd like to invite Mr. Ajay Kumar. Thank you.
Good morning, everyone. Yeah, I will be presenting to you the Astra solution that is a mandated project given by DOT to CDOT, and we are the implementers. So Astra is AI and facial recognition powered solution for telecom SIM subscriber verification. So there are, it is a quite long name. So there are some points to be noted here that it is a proactive tool. So before a fraud is committed, so we are trying to detect the frauds, and it is an AIML tool, and it is generating intelligence which is helping some other stakeholders like LEAs also in tackling those frauds. So indirectly we are targeting the base which is the SIM cards. So most of the cyber crimes are being done using the telecommunication resources, using the SIM cards. So we are trying to find out whether the SIM card is a genuine one or whether it has been taken on fake or forged documents. So first I will talk about the menace of cyber frauds and crimes. So this is one of the surveys done by local circles, and it is saying that 47% of urban Indian households surveyed confirm experiencing one or more financial frauds in last 3 years. So considering the population of India, India being number one in the world, 47% is a huge number. So those many people are experiencing financial frauds, and I'm sure many of the people in this hall, they must have got some fake call, or you can say fake email. So recently I got an email from claiming to be from CBI. So at first I was really frightened to see that email, but when I saw its uh, email sender, so it was from a Gmail ID, so it was not an official one. So you can only imagine, if I am working in this area and I got frightened, what can be, what could have happened to a normal person. So similarly, I got a call also, and somehow I was convinced. These fraudsters are so convincing. So he claimed that something is going against you. So later I realized that it might have been a fraudulent call. So just I want to say that it is a menace that is going on these days, and it has to be tackled. And one of the way of tackling it, targeting at the root of it, that is we are doing through Astra project. So this is another clipping from Business Standard. So online scams drain rupees 4245 crore in just 10 months. So it is a 2025 data, and it is also affecting the economy of country as a whole. So again, I'm emphasizing that these frauds must be stopped. So at the center stage is the fraud, and I will be talking about the financial fraud. So these are some of the common financial frauds, like fake SIM cards. So this is the one which I will be talking about. So fraudsters are able to get the SIM cards in someone other's names, using someone other's demographic details like name, father's name, address, date of birth, and using someone else's image also. So I will show you some of the collages where hundreds of SIM cards are taken using the same image. And there is a SIM swap fraud, in which the fraudster somehow convinces the TSP that he is the genuine user, and he gets the SIM card issued in his name. And all the OTPs, SMSs, calls will reach him, and he can easily use those OTPs to change the passwords of the bank, and he can easily do frauds. Phishing is another common fraud, where an email will come to you and claiming to be genuine one, and you will somehow disclose your secret information like credit card information or OTPs or other bank account numbers on those emails. So phishing is another kind of fraud, where voice call will come and he will claim to be a genuine party, and you will disclose on the call itself your critical information. And spoofing frauds are those where caller ID is manipulated, and it is claiming to be from a genuine one, and email address is also claiming to be a genuine one, but you somehow don't realize it and fall its prey. So these are another instances where some SMSs are coming from some SBI, and but link doesn't belong to SBI. So you click on this link and you may get into some trap. So these are some of the cybercrime hotspots. So cheating in the name of customer care. So gangs are present in Bharatpur and Alwar in Rajasthan, Mewat in Haryana, and then Noida. So ATM fraud gangs are operational in Mewat and Bihar, which is Jamtara. Fake links and OTP frauds are happening in Jamtara district. And social media kind of frauds are being concentrated in Delhi, Noida. Video calling frauds, these are being done in Alwar, Bharatpur, and again Mewati in Haryana. So this is the financial fraud cycle. So SIM is taken on third party document. So they forge the document like Aadhaar card, POI and POA documents, proof of identity and proof of address, and they use this to get the SIM cards. Then they open the mule bank accounts or some Paytm wallets, and they will then impersonate using and will try to attack the uh, uh, victim through phishing, wishing or other means, SMSing also. And once they get the credentials, they will do financial frauds, and it will be diverted to multiple bank accounts and it will be taken. So this is the financial fraud cycle, and at the top of it is the SIM card through which this is being done. So we are trying to break this chain by detecting the fraudulent SIM cards. So here, even if there is some investigation, so the actual fraudsters will not be caught because he is anonymous. He is using someone else's POI and PO documents. He is using someone else's image. So even if someone is caught, he will be someone different, not the fraudsters. So untraceability is there, and these are transborder syndicates, and 70% cases which are currently under investigation, and less than 5% they are that is the conviction rate. So so there arises the need to tackle this fake SIM frauds. So according to a study, cybercrime will cost the world around $17.65 trillion annually through by this year. So it is a huge number. So these are some of the fake POI and POA documents. So in the first case, you can see the Aadhaar number is same, but the name is different. Image is same. So here is Jutika Sarkar and here is Subala Sarkar. So in the bottom three fake documents, the name is same, the image is same, but he has forged the Aadhaar number. So these are also fake documents. But using these fake documents, they are able to get the SIM cards. So this is the misuse of telecom resources. So telecom resources are a very prominent source for making these frauds. So syndicates are creating fake POI, PO documents. They are constantly changing their name. They are using someone else's father's name, date of birth, address, or other KYC details. Then they reuse same image, and often they are also disguised, like they are using some chunnis. The male, sometimes he is posing as male, sometimes he is posing as female also. And then earlier there was conventional text-based analytics was done. So only subscriber details records were analyzed, and when looking at the subscriber detail records, you can only see that these are all genuine ones. You cannot tell whether they are related or not. But when image is combined with it, so you come to know that same image is used with all those connections. So in that case, the fraud was caught. So this is the proactive AI-powered digital intelligence tool. So it is detecting and weeding out the fake SIMs before used for cybercrimes. Second is prevention of cybercrimes and frauds, because if you are removing the SIM cards, fake SIM cards from the system, then obviously cybercrimes will be reduced, and it is then catalyzing the investigation of cybercrimes. So we are also generating intelligence regarding the POS agents, point of sale agents, and sharing with the LEAs also, so that they could file the FIR against them. So this is a face comparison that we are doing. So the basic technology we are using is face recognition and face clustering. Along with it, we are using the fuzzy logic for the text relationship. So for example, two names are there, Naveen and Naveen. So they will be categorized as one single name. That is a fuzzy logic. And by using SIM verification tool, at least 1000 times the SIM verification has increased. So, and now Astra is agnostic to these fake POI and POI documents. So we are detecting the fraud because by detecting that same image is used, but different names are used. For example, his name may be different, his father name may be different, he may be using different date of birth or different address. So if his demographic details is changing but image is same, then we are claiming that it is a fraud. Similarly, if individual subscribers, in case there is a limit on getting the number of connections. So in India it is 9. So if we detect any number of connections to be more than 9 in a particular set of collage, then we claim that it is a fraud. So this is one of the sample cases of fraud. So here the person is posing as male as well as female, and we are detecting him as a one person. He has taken 7 SIM cards. He has used 3 names. So this is a confirmed fraud. In this case, he has taken 52 SIM cards in his name, using 25 different names, both male as well as female, and Astra detects it as one fraud. So this is the same image being used for taking 213 SIMs across different DSPs, and they have used 100 different names, using 100 different forged or fake documents. So Astra detects it as one fraud. So there are numerous examples where even we have generated 1,000 images collages also. So, and often the POS are involved in it. So it cannot be done without the involvement or collusion of POS. So we are generating intelligence about those POS and also sharing with the LES. So these are some of the stats. So we have analyzed total 134 crore connections and detected suspect connections approximately 81 lakh, and TSPs have disconnected 77 lakh after re-verification, and POS agents who are blacklisted are 71,000 so far. Total FIRs registered are 365, and total number of POS who are mentioned in these FIRs are 1,890. So this is another sample example where 100 SIMs are taken using 76 different names. So these are some of the POS analysis. So on the left side we have POS who are selling more than 5 fake SIMs, and on the right side we have POS selling more than 10 fake SIMs. So you can see that the concentration of those POS, they are lying in mostly in West Bengal. It is a highly dark area. So both in the case of 5 as well as 10 fake SIM cards, West Bengal is the hotspot. So this is an impact of Astra. So in Mewat area earlier there were 5 lakh fake SIM cards, and it was reduced to 65 fake SIM cards in just 1 year. So that is the impact, and it is there in the news. This is another application of Astra. It was used during Balasore train accident, where around more than 80 bodies, they were unclaimed bodies, and they were highly disfigured also. So DOT approached us, and we tried to find out, and approximately all those 80 bodies we could find out their SDRs, their address, their mobile numbers, and shared with the LEAs, share with and also the disaster relief agencies. Yeah, these are some of the awards that we have won. So we have won the 8th E Northeast Award 23 for Astra. We have won 14th Aegis Graham Bell Award 24 for Astra. We have won Alcina Definition Award 24 for Astra. These are some of the news clippings about the Astra. You can go through these. Yeah. Then it is related with the AI, the concept of responsible AI. So I call responsible AI with the acronym of FAP. So FAP is the fairness, it is the explainability, and it is the privacy. So every AI system must be responsible. AI, as you know, is imitating the human behavior, and human, as you know, can be responsible as well as irresponsible. So in the same way, AI can be responsible as well as irresponsible. So we have to make a responsible AI solution. So what I mean by responsible, I will cover the fairness example. So there was a situation in 2021, someone searched the ugliest language in India, so in the Google search engine. And it resulted as Kannada was the ugliest language in India. It was in 2021. So this caused really the widespread outrage in Karnataka, because how can it be a ugliest language in India? So Google then, how did this happen? So Google algorithm aggregated user generated content from forums and blogs. So it got all the data for training from the net, be it blogs or somewhere else. And they were not authenticated feedbacks. They were users general feedback. So some bias was there in that content, and Google did not realize, and it trained its model using that data. So hence that kind of the answer resulted. So public reaction was obvious. So it was a massive backlash on social media, and Karnataka government also demanded an apology and explanation. Citizens were protesting. So what was the Google response? First, it apologized and removed the offensive search result. Then Google acknowledged the importance of cultural sensitivity. So here I would like to stress upon this one aspect, the cultural sensitivity. The models are being created in the West. They are trained on their model. They may not work here on Indian culture, or may not work in some other culture. So they have to be trained on Indian data. They cannot be directly used. So this is a prominent example of that problem. So Astras, we have also used our face recognition models. We are actually trying to improve those face recognition models using Indian images. So still there are problems regarding the people who are present in, say, Rajasthan or Punjab. The Western models is not trained according to those faces. So we are not claiming 100% accuracy, but we are claiming approximately 98% accuracy right now, and in the process of training our own model. So these are the key takeaways. AI and search algorithms can amplify biases from online content. So what I can say is algorithm is not bad. Algorithm is always good, but the data with which it is trained, that is good or bad. So the data cleaning is a must before training any AI model. So cultural sensitivity is crucial. So it has to be taken care, and then companies must implement better oversight. Yeah, they must recheck before making their models or solutions public. Yeah, thank you. Yeah, any questions?
So thank you, Mr. Ajay Kumar, for your presentation on Astra. So now, as a token of gratitude and respect for all the speakers and their technical topics, I would like to request Shri Dev Kumar Chakrabarti sir, member designate, to come to the dais for presenting the mementos to the esteemed speakers. And I like to call the speakers also one by one. Okay. Yeah. So I'd like to call Shri Bapi Chatterjee first. Next, I would invite Mr. Sachi Mukhopadhyay to next, I invite Mr. Kaushik Dey to take his memento. Next, I would like to invite Mr. Ajay Kumar to please take his memento. So now the technical session is now closed, and I request all the dignitaries and the participants to proceed for high tea. We will be starting the next focus group on AIN and working group 2 meeting sharp at 11:30 in this hall. Thank you.
we should get started, I think, for the meeting.
Yes, actually, I was just checking if the people remotely connected can hear us and if they can speak and confirm, please.
Yes, we can hear.
Yeah,
Hi, Xiaomi.
Xiaomi, good morning or afternoon.
Yes, I hope you can hear us as well.
Yes, yes. Ricardo, are you ready?
I'm ready, but yeah. Should we wait for a few more moments? We can start right away.
Okay, just 1 minute. Let me try to call people. Just 1 minute.
Okay, yes. Meanwhile, I can just welcome all the people remotely connected. And Buze, please, we can proceed as yesterday, of course. You can open the works and then we can assist you for the chairing, let's say, in presence. Today we should start with the VG2 session, right? So I hope the chair of VG2 are connected so they can lead the presentations of the documents. Is that okay, Buze, please?
Yes, yes, Ricardo, thank you so much. So I'm checking
Hello.
the chat. Yeah.
I'm Ranjana Shivram. I am the working group co-chair. So I am present in the meeting and I'll be leading it, like presenting the agenda and then calling the speakers one by one.
Perfect. So let us start with the general agenda, the going over the today's agenda. So Thomas, if you can share the agenda for.
Yes, just 1 minute and Thomas will
Sure,
share.
sure. Yes, thank you. So, thank you everyone for joining today's session. We have a slight update after yesterday's discussion. So, as Ricardo mentioned, we'll start with the VG2 item. We have the contribution and really interesting discussion, and then after all the contribution, we'll go over the VG2 deliverable status, and we'll conclude the VG2 the meeting, and we'll have a lunch break. After the lunch break, we will have the VG3 and 4 discussions, and after that, we have two management documents. The one is the contribution and deliverable approval process, and the other one is collaboration, the MAP, which I will briefly introduce. And then we'll go over the liaisons statement. After that, we'll have two important discussions. One is the collaboration. One is related regarding to the collaboration between the FGIN and CG datasets. And then the last item is about the deliverable that we go over yesterday. As you all know, the Marco had a great job and shared the clean version of the deliverable documents. So he will introduce the documents after that. So this is the today's agenda. So is there any other point that anyone wants to add into the agenda, we can start with the VG2 meeting, and I can give the floor to Ranjana.
Thank you, Buze. Thomas, will you please show the draft WG2 agenda? Okay, sorry. Once Vishnu ji has raised his hand, yeah.
Busa, just quick question. There are two parallel sessions. One is for, I mean, both are for the Thon actually. One is just now, that is going on just now, just to mention that. And another is, I think, 4:30 4:30 local time. I think that is the parallel sessions. That will go on in parallel with this. Just wanted to mention that. Another thing is liaison statements. So do we have a small slot for liaison statements?
Uh, Let me answer the both of them. So I shared the agenda with everyone. So we already know that there is a parallel event, the Build-a-thon event, and everyone is approved. So there is no any comments regarding to this. So I'm not expecting any trouble because of this co-event. So this is the answer of the first question. The second one I already introduced. There is a slot, of course. The eighth item in the agenda is the liaison statement. We'll have the four documents to discuss there. So it's already in the agenda. Thank you.
Thank you very much, Susan. Thank you very much, Susan. We can go ahead.
Thomas, would you be showing the agenda for the WG2 meeting? Notice raise hands. Oh, it is clickable. Zoom in, please. It's very small. It's okay now. So welcome to the working group 2 meeting. So scrolling down. We have to scroll down. So now we have to carry out the approval of the agenda. So we'll review the meeting minutes of the previous meeting of the working group 2. It's just a short summary. So it can be opened from the focus group side. Should I show it from my end? One second. Should I show it from my end? Okay.
Sorry, we are having technical issues from our side. So
Okay.
for the access, Shabais has to give you the access. So just asked her to do that now.
Okay.
Yeah.
Okay. So this is a summary of the work done from the previous meeting. So going forward to section 2 working group 2 meetings. So working group 2 interim meetings were held on 8th May and then 22nd May, and then we had one meeting on 5th of June. So multiple contributions were presented and then reviewed. So they are first input document number 069, which was AI inference as a service in AI native telecommunication networks, and revision 1. Then there was document number 70, which is use case AI training as a service in AI native telecommunication networks. Then document number 71, which is LLMs in AI native telecommunication networks. Then we also had discussion on document number 59, which is use case on communication and coordination for multiple AI agents. Then we had document number 54, AI native networks as applied in the verticals. And then we also had discussion on document number 5, which is LLM agent powered intent-based network slicing for industrial automation. So some of the documents were discussed and then revised, but none of these have been finalized completely as yet. So some of these documents, after the revision appropriately, we will be taking them up now in this meeting. So the expected output of the working group 2 in section 3. So the output is technical specification, which will be having use cases for AI native telecommunication networks, and it will accumulate the typical use cases, and each use case will provide motivation, description, indicate the assumptions, and as well as analyze potential requirements for each use case. So currently the output deliverable is as in focus group document number 084. And it includes the contribution which is based on document working group 2006 revision 3, which was approved in the previous April working group 2 meeting. So working group 2 timeline and milestones. So taking it from focus group 3rd meeting, which is happening now in June, we'll be updating the working group 2 deliverable with a list of requirements as per the finalized contributions. Then in July 2025, we'll be finalizing the contribution plan. Then in August 2025, we'll be closing the pipeline for the deliverables. In September and October, we'll be reviewing and refining the working group 2 deliverables, and then we'll also be completing it. So these are the milestones. So the documents for discussion in this 3rd meeting are the contributions that have been submitted and the draft output of the working group 2 deliverable. So now I close this summary of close this document regarding report of the previous work done in this working group 2. So now I show the agenda. Is the document available? So I can take the later. So I can stand here. This should be Antonio. Okay. So now I invite Antonio to present the contribution AI inference as a service in AI native telecommunication networks. So it is document number 109.
Thank you.
No.
Thank you, Chair. Would you share it, please? Can you hear me?
Yes, Antonio, we can hear you. Probably we will give you the sharing capability. Just a moment, Antonio. You can share directly, Antonio. Probably it will be easier for you to present. You should be able to share.
Yes. Okay. Let me open then the document. Sorry, because I didn't have it ready. Okay. Okay. I hope you can see my screen.
Yes.
Okay. Then, okay. First of all, maybe I will quickly recap the comment received about these 3 use cases during Istanbul meeting for the understanding of the audience. There were actually, from my perspective, few minor comments. One comment was from ZTE related to only 2 of them, the AI inference as a service, AI training as a service. The colleague from ZTE was suggesting to have only 1 use case. Actually, at the time, we already replied to this comment. Since the requirement of the use case
Antonio,
are different.
Can you zoom in? We cannot see.
I will zoom in.
Yeah.
Is this okay? Yes. What I was saying is that since the 2 use cases different requirement, we prefer to present them as as different use cases. However, when we will, we will present in the following meeting from working group 3 the architecture that enable these use cases. Actually will be a single contribution from that perspective. Then there were a couple of comments from Ibrahim and Marco that were suggesting to enhance let's say the readability of the figure of the use cases, to highlight which put a legend basically and highlight where the intelligence was in this pictorial representation, and give a bit more information about that. And during the last working group meeting where I started actually to present this, there was also a comment from the chair to include an additional requirement related to the database. But I will go through this minor comment, then starting from this use case. Okay, so one comment was highlighted during the last meeting was that about this reference on the definition of artificial intelligence, which was actually missing from the document. So yes, so we add it, and actually thank you, Chair, for the for spotting this. And this is the actual reference from ISO about the terminology. Okay. The other comment from the chair were this about the repository. The repository for the data that has to be used to construct the model, so the data used during, let's say, the model life cycle, and as well, so also the data that is used as an input and is produced as output of the model itself is stored in this data. Here we are talking about inference, but obviously the same repository can be used for training or an inference, at least from a from a functional perspective. And then AI model repository, which is the repository where the models are stored and can be collected for inference. Okay, so these two, let's say, repository were already listed in the document in the actors and roles. But we, at the beginning, we had chosen to not put it as a requirement, let's say, because they are not functional or performance requirement. But it was a good point to add it because yes, this still they are needed for the model life cycle. Then we have updated the figure as mentioned earlier, and also adjusted a bit the description related to the figure to align basically the text and the figure itself. Okay, I will show you the figure maybe, and then we can have a look at the specific change. So basically there are three sub-figure in the figure itself, which reflect three different, let's say, sub-cases of the same use case. Okay, again, we are talking here about AI inference as a service. So the case in which the AI-native telecommunication network provide to an application, to a customer, to another function, the inference offer the inference capability, right? So what you can see here, so there are, as I was saying, there are three use cases, A, B, and C. So what are the difference? In this first, let's say, use case, the inference is completely realized, let's say, within the telecommunication network. okay? In the second use case, also the environment, what we call environment of the AI native telecommunication network, environment which is defined in our the definition of AI native telecommunication network, participate to the inference, in this case, a device, and the data network, so a server related in the data network. And then the third use case is the use case in which multiple different type of data are used together at the inference, are processed together and input to realize the inference, and some additional level of intelligence of orchestration is needed in the high-needed telecommunication network to process this different type of data. Okay. What I want to highlight is that okay, we had added this in this legend where you can see that basically what are the elements, the important elements in this pictorial representation. First thing, the AI model orchestrator, which is the actual intelligence in the inference, or let's say in the model lifecycle, okay, that manage the AI model lifecycle, so that allocate the resources, that take decision and so on, okay. While the AI model inference participant is a node inside or a function inside the telecommunication network that has inference capability, which means has AI resources, computational, storage, and data basically available, but is not is not capable of taking, let's say, decision. It execute what the orchestrator decide, basically, right? What else? You can see in a dashed line the interaction. In particular, what we discuss in this use case is also the possibility that the orchestrator not only decide which resources are allocated, which model to be used for a given inference service, but also how the model is, the workload is split between different nodes which execute the inference between the different participants, okay? And you can see in solid line the data traffic transmission that is used for the model inference. As I said before, the model orchestrator is the, let's say, the intelligence. That's why we have put this wheel here that highlight orchestration capability at the orchestration level, okay? And yeah, I don't think the other aspect, okay, the other icon, I think are pretty clear, okay? So yes, these small changes reflect let's say, this detail that I described here, okay? And there are no other changes in the test or in the document. So if there are some questions, I will be happy maybe to take them before to go to the next use case. Any question?
So there are no questions, so we can move on to the next use case. Sorry? Oh, okay. Sorry, I didn't see. Marco has raised his hand. So over to you, Marco. You can raise your question.
Thank you. No problem. It's a minor point because obviously we are reviewed internally this document, so I don't have a specific. I want just note one point, Antonio, for the future when we will consolidate the requirements. I didn't ask internally. I see, for example, for the new requirement, you use the term in terms of requirement should, no? Which is a recommendation. Why we may be optional, it may be required, is required. So I want just to ask, should we review the strength of this requirement, or it was on purpose that, for example, this new requirement contains should and not is required, for example. But this is not the point to be solved immediately. What I want to say is that we'll have to check the strength of the requirement when we are going to consolidate all. I'm sorry for this point. Thank you.
Marco, thanks. So I don't know from a deliverable perspective if there is a specific, let's say, syntax for the requirement, or whether they should be expressed as a requirement or a, because basically my understanding is that the syntax depends whether then the document is proposed as a technical report or as a recommendation, right?
Yeah, Antonio, you are right, but in general, no problem, no problem. We can move on. What I'm saying is that even in a technical report that is not normative, usually we had the habit to distinguish, for example, from is critical. We don't use
Is
requirement.
expected,
Is
is
critical, is
valuable.
expected to show
Yes,
different
yes.
levels, right? In this sense, no
I
problem. We
understand.
can
No,
move
but here
on.
we haven't choose to have because our use case a requirement, not architectural one, so we have not chosen to distinguish them. We thought that they are all valuable. I mean, for the specific use case, they are all valuable.
Can discuss in the future, no problem. Thank you.
Okay, thank you. So I will move to the second use case. If
One
there are no
second.
other.
Sorry.
Sorry. Hello, Antonio.
Yes.
Please, Chair.
Yeah, can you hear me? Just one quick question. So I see that in the actors and roles, so there is a AML model orchestrator, and also in the figure you have described some descriptions for this model orchestrator. So I just wonder if there are any requirements, functional requirements for this. Yes, for this function or.
Yes, so you see there are functional requirements here. Okay, so okay, the function basically we use the functional requirement to sketch this high level, let's say, representation, and then we'll based on this also to develop the architecture of this to support this use case. But yes, these are here. Function support the complete ML model lifecycle as the joint optimization of connection, data collection, processing, algorithm model, okay? Monitoring the status of AI resources, the AI service performance requirement, prioritize requirement between inference as a service and the service offered by the network, determine the AI model to use, update the AI model based on when the communication of the AI resources or the service requirement change, splitting the AI inference workload, transfer additional layer of AI model to increase the model performance upon the change of a network condition, monitoring, optimize the AI inference workload and its split. All these requirements are related to the functionalities that will be present in working group 3, and most of the a lot of them are actually implemented in the at the orchestrator level.
Okay, so I understood. So all the functional requirements to support the ML model life cycles would be belongs to the orchestrator. Okay.
No. Only the, let's say, the one for which there is a required decision making, intelligence, and so on. Okay, the processing functionalities will be realized at the participant. Okay, the data processing, the data storage, the inference itself. Okay, so part of them are realized at the model orchestrator level, and part of them at the model inference participant. But this is detailed at working group 3 level, I think.
Okay, so yeah, I got that. Thank you, Antonio.
Thank you.
present your next contribution, which is 110.
Okay. So yes, these two contributions are pretty much related. It's the counterpart, let's say, the AI training as a service. Okay, as you can imagine, in this case, the network provide the training service to, as I said before, users, application, and so on. We have added the same reference as required in the other document. Similar additional requirement, okay? The AI model data repository, and the AI model repository. Okay, I hope that the difference between the two repository is clear. And then here we have a single figure, so minor, let's say minor changes with respect to the previous one, but actually that reflect a similar, let's say, similar high-level description, right? In this case, there is again the let's say the orchestrator and training participant, okay, and two instances of AI training as a service, okay, meaning that we are training two different models at the same time for two different applications, and you can see the different interaction and the let's say the actors which have a role in this representation. Okay, so yes, here the difference are with respect to the original document are minor. With respect to the AI service, AI inference as a service. Any comment?
There's no comments, so we can move to the next contribution, which is 111, and Antonio, you can present it.
Okay. Sorry if the number that I'm using opening in my my local are not the latest one, but yeah, the document is the same. I could have opened it online actually. So here there are a couple of difference in the references. Okay, one is this reference from ETSI. Okay, and the other one is the MCP protocol. This reference. So so ETSI. This is about the AI agent work, and MCP is Model Context Protocol, which is becoming, I would say, the de facto standard from industrial perspective, let's say, for communication between LLM agents. Okay, so it's I used this. Provided this reference, this model is developed by Anthropic, and in this web page there is a description of the model itself. Also in this document we have included the reference of the document from ISO about the vocabulary. Here there is a clarification regarding one of the functionalities, just a minor update, I would say. So the intelligent mechanism regarding the LLM performance evaluation just added that this performance is based on the use case requirement. And we can term this evaluation as well as LLM benchmarking. The additional requirement, okay, two of them are related to the repository, okay, and the other is related to a knowledge base. A knowledge base which define all the, let's say, allow the LLM agent to support new added value services by looking for various type of data, such document, database, or also using additional tool like search engine to retrieve relevant data at the inference level. No? And these are the, let's say, the two new subfigure that let's say add some level of detail, some level of information which were missing in the previous or clarification which were missing in the previous version of the figure. Okay, in particular, based on Ibrahim comment, I think indicate where there is the AI agent or the LLM. Okay, in these figures. One is basically the representation of an LLM-based intent-driven network. Okay. In which the LLM, similar, I would say, to some other use cases, the LLM support some decision making and policy, network policy configuration based on the intent coming from the user, which is translated by an LLM, while the AI agent is capable of analyze, let's say, the policy with respect to the intent and take decision based on the network configuration. So, and in the second case, basically, it's I would say reflect one aspect also of this figure above, where AI agents are capable of providing network policy evaluation. Basically, a set of agents, a chain of agents, construct like a digital twin of the network to provide the let's say the policy evaluation, okay, using different data available from the network, the policy information, let's say configuration, coding capabilities, okay, obviously, and a set of models that can be run by the agent to evaluate the policy. Any comment?
There is one floor request. Hiking, you can have the floor, please.
Yeah, hello, Antonio. So, one editorial comments for this use case is that the use case name. So I think that to be confirmed, because you have two different names. One is in this in the cover page, and the use case in AI native telecommunication network, and in the table, the use case name is native LLMs in telecommunication networks.
Let me, sorry, thank you, Chair, for spotting this. Okay, I will share an update to harmonizing this. Sorry about that.
Okay.
Or do you want that I adjust it right now? I can also do this, as you prefer.
Yeah, you can just revise that, and
share.
For the figure one, sorry, I'm. Yeah, the figure one. So now you have two figures or one figure?
Now, in figure 1, there are two subfigures, okay? Which,
okay, two subfigure.
Basically, this the bottom figure represent, let's say, a part what is happening here, okay? You see, provide this policy evaluation here. So it's, level of give a level of detail of what is happening in this red box.
Okay, so you will have multiple AI agents inside the network to support maybe the including the policy configuration or some results scheduling or something like that, or just so what is this multiple AI agents used for? Just so what do you mean here in the network analysis box?
Okay, so so basically the idea is that at different level the network can be analyzed and optimize the different network policies. Okay, so imagine that there is the need to reduce the energy consumption, right, of the network. So you want to update the energy saving policy, okay, that tell you, sorry, from at which time to activate giving energy saving mechanism, which are all the configuration related to this mechanism, and so on and so forth. Okay, so so let's imagine that the intent is, okay, I want to reduce of 1% the energy consumption of the network. Okay, so then this box will analyze the energy saving policy and provide a representation information to this decision making box to take decision. Okay, it evaluates the current policy or additional configuration of the same policy. Okay, it's, as I was saying, is like giving running a network digital twin inside the network itself. Okay.
Okay, so it's used for the policy evaluation, and
exactly. In this figure here, AI agents are used for policy evaluation.
Okay, is there any requirements in the functional requirements or somewhere?
Yes. So you have functional requirements, both from AI telecommunication network functional requirements and LLM functional requirements, LLM specific, let's say, functional requirements. Okay. Then we have performance requirements and additional requirements.
Okay.
Okay.
Okay. So in the additional requirements,
yes,
which you have, yeah, it's the update one. So I'm a bit confusing that to all these requirements are for supporting the new added value service. So what is the added value service for this use case?
So the added value services is the service of the use case. Is providing LLM natively inside the network, okay, for different purposes. So in our definition here, you mean what is added value service? What does it mean, or what is the added value service here in this specific use case? What is your question, Eugene? Sorry.
Yeah. My question is that do you mean that the LLM based the capability could be a newly added value services for for some applications or for the users. Is that is
No,
my
the
understanding
LLM
correct?
is not a service for me. The LLM enable services, or it's also a service as a itself, but more as a chat box. It's I would say, okay. In this case, you see this the use case description, okay. So LLM provide different type of services, okay, semantic capabilities, intelligent access to knowledge, and LLM as a
Okay.
orchestrator, okay?
Yeah. Oh, okay. I see that. So all the new value-added services include the following three capabilities. Okay. I got it. Okay. Thank you, Antonio.
Thank you, Chin.
Are there any further questions on this contribution? So if there are no further questions, what I would like to propose here is that since these three contributions, input document number 109, 110 and 111, we could, Antonio, could you try to extract the requirements from these use cases and put them into document number 84. So the document number 84 is the output deliverable of the working group 2, and I think that we should try to extract the use cases that are sort of finalized now and then put it into that, so that we can review it also and then further build upon it. So like in the initial discussion, Marco was mentioning that the requirements within that, there is a convention that the requirements, use case requirements have to be divided into what is critical, what is expected and what is good to have. So you could try doing that, and maybe at least one of the contributions, like at least 109, if you put it into I-104, a revision document, and then you are able to mail it back to us, maybe in the second session today itself, which is from 12:30 to 1:30, we could have a discussion.
Okay.
Lucy, what do you think? Is it a good way to go forward?
Yeah, I think it's okay to. Yeah. Sorry.
No, please go. I thought that she said Buse. That's why I interrupted. But please, I think yeah, my bad. Sorry.
So sorry, only the requirement, right?
Yes, all of the requirements. But if you are able to, like it depends. If you feel that whatever requirements are given in your use case, they are all critical, then they will be put into the. They should
No,
be put into
this is clear. This is clear, Chair.
Okay.
What I mean is, do you want that I explain? Okay, I will do this. Maybe in a table, I can have
Yes, if you
per use case.
Yes.
Or okay, perfect.
If
I
you
will
go
do
through the
this.
document 84, one of the contributions which was finalized in an earlier meeting was already put into the document. So you will get an idea.
Okay. Can you say it again, the number of documents? Sorry, but I can find it actually.
It is 84, 084, and
84.
it is in the focus group, main focus group, input document area.
Yeah, sure. No problem. I will do this.
Okay.
Sure.
Thank you. So
Thank
now
you.
we can move to the next input contribution, which is I-102. So I'd like the contributor would be showing the document. Okay, so you share. It is better for scrolling, etc. So as a contributor, you can share it yourself.
Uh, so, I'm Avijan Bhattacharya, representing here Telecom Standardization Society, Development Society of India. What we are proposing here is the support for native APIs for dynamic distribution of inference task in an edge cloud continuum. Abstract is, so basically, while splitting the deep neural networks or any artificial neural networks, the AI splitting is already considered as one of the use cases. And in this one, we want to put the use case and requirements for support for native APIs. So network applications on IMT 2020 and beyond are depending heavily on deep neural network. However, DNN-based applications typically require significant computation and energy, both in terms of required computation overhead and energy consumption. Hence, rather than supporting them on end-user equipment, we, especially on constrained devices, the alternative option is to approximate them, but that will sacrifice the accuracy. So it will go, so the training and inference, everything is, partitioned or offloaded. But offloading also has a latency penalty, and that is why we talk about splitting. I'm not going into much details about why we do the splitting and the description, because we already had one discussion related to that. In 6G, the kind of scenario we are interested in here is that in IMT 2030, we are talking about edge cloud continuum with, and as AI support, support for native AI in applications are going to be norm as part of network for AI. Such continuum needs to be used for distribution of the AI splitting. So this can happen like a cloud can act as an orchestrator, which can allow the or which decides on the point to split, and then the head and tail segments get split between the user equipment and the edge component. Why we need this cloud involvement? Because given a certain condition of the network and the resource load on the individual EV and the edge, finding the right point to split itself is a challenging problem and is non-trivial problem. So, and it involves a lot of computation there itself. And the other thing is that cloud involvement is necessary because 3GPP has already published a TR where it has said that UVs may not store the ANNs in the first place because they are going to be stored in an ANN cloud and on demand, depending on what type of action is being carried out, the ANN may be loaded. And at that very point, while loading, a dynamic split point can be decided. That is what we have said in the second point. Identifying the optimal layer to split the DNN dynamically is a complex problem. It depends on multiple factors, the type of the DNN, because ultimately you have to decide that at which point in the graph it is to be split, accuracy required by the application, and then instantaneously available resources at both EV and the edge, network condition between each pair of the three entities here, EV, edge, and the cloud. So the cloud can take the role of such control plane activity instead of performing the actual inference and distribute the task. So to enable such complex operation, there must be standardized APIs natively supported in such network ecosystem of future. This will help end application developments for putting embodied intelligence, sorry for the typo, embodied intelligence on the UEs to be agnostic of the underlying complexity. On this background, this document proposes a use case and requirements to enable native API support for dynamic distribution of DNN workload in an edge cloud continuum. And this also considers the dynamic model transfer aspect along with split decision. The existing work that has been identified and the gaps identified. So 3GPP has already published a TR considering the holistic aspects and application scenarios for AI model transfer. Splitting of AI models have been considered as part of this overall topic. However, the architectural support that is needed with native APIs for dynamic model transfer and split decision has not been included. Although there has been some discussions on how splitting can be done, and academic literatures have been referenced. And as we just discussed few minutes ago, there is already an FGINN document which proposes the use case for AI inference as a service and discusses AI splitting as part of such inference enablers. And it talks also about multiple components, splitting into multiple components, right? But the specific use cases to support for native APIs and all, these are not put in the scope. So we try to understand, we try to enhance this that way. And let me go straight to the description. And although this is not an architecture document, but still we have tried to put an architecture so that the workflow that we have perceived is is explainable. This use case proposes to enable native API support for on-demand DNN model transfer along with dynamic distribution of workload between the edge and the cloud. The scenario is depicted in figure 1, the possible arrangement of necessary entities and interactions amongst themselves. So this is not something hard and fast. This is just a conceptual thing. So the way it is perceived is that there will be a split decision engine which will be distributed across the end terminal and the edge cloud continuum. And that engine is basically what will be abstracted by the APIs. So on the UE side, this engine is going to get the model request based on the instantaneous application demand. And it is going to also, if possible, will do some edge discovery in the nearby and equip the cloud that this is my condition. And at the same time, the cloud will understand that, okay, this is the this is what the resource state, this is what the current edge neighborhood, and based on that, it will also go through its own learning that it has its own profile. What are the profiles of the for that model for the desired type of inputs? So the input type, the resource conditions, network conditions, neighborhood, all these details are actually provided to the cloud a priori just when the EV knows that it has to go for a AI algorithm to be to execute an AI algorithm. And based on that, the head segment and tail segments are decided and transferred to the edge concerned and to the EV concerned. This is the idea based on which the APIs are to be conceived as per this document what we are proposing over here. So I'm not going into details of the steps that I have mentioned because I just summarized it. So the KPIs will actually depend on the latency and resource efficiency demanded for the particular application, and we can have a study separately on that. And open issues are finding the optimal split position and what are the exact data that is required. It is still not very clear because of the dynamism of the models itself and the variety of the models itself. and also the conditions and application types, right? So that can be that needs to be looked at, and the model transfer complexity, because transferring the model itself needs certain network resources. So that complexity is yet to be decided, because this has to be dynamic and almost real time. We have given about 12 requirements that we could think as of now. This can grow, this can shrink based on the comments. So as we said, the API should allow to discover the nearest edge computing with necessary resources. API should essentially enable the application to access the splitting decision functions distributed across the UE, edge, and cloud entities. APIs at the UE side should enable the UE application to advertise the instant model requirements and the desired accuracy. API should allow access to low-level channel properties for all the three pairs of links among the three entities, cloud, UE, and edge. API should enable smooth transfer of the head and tail segments from the ANN store through the split decision engine at the cloud. Once the model is received at the UE and at the edge, the API should allow efficient abstraction for smooth runtime integration into the application logic through pre-configured hooks within the application program for both the UE and the edge. So the application is basically the container where the head and tail segments are actually coming in runtime. So we have to, to make the life of the developer easy, there should be proper API support so that the developer only calls these APIs and does not have to worry much about how to stitch the varieties of segments that are coming, how to stitch them together with the existing business logic or business application. API should provide fail-safe mechanism by enabling graceful performance degradation or termination in case of non-availability of edge computing infrastructure on demand. So once it starts executing, suddenly the edge may disappear for many reasons. It may get corrupted. There may be mobility, because the edge may be mobile and it suddenly picks up speed and just goes out of range. Anything can happen. So there should be enough fail-safe mechanism either to pre-terminate in a graceful manner the entire logic. Otherwise, it may cause too much of a problem for the end application. The API should have privacy filters to allow end application restrict or customize information exposure for split decision functions, and the related impact on decision outcome should be handled gracefully. The API should enable sufficient authorization and trust establishment among all the entities. The API should enable secure exchanges and especially should enable to protect the models from any partial or full adversarial attacks, because when the model is being transferred, as per the adversarial nature of adversarial attack on DNN, even a small chunk, data chunk, if it gets attacked, if somebody an eavesdropper can just is able to tamper at least one chunk, then also the entire inference becomes completely different. Okay, and this is a well-known problem in the attack models on DNNs. So there should be proper protection against all sorts of adversarial attacks when the model is in transit. The API should enable lossless compression and decompression of the head and tail segments in transit if such lossless model compression mechanisms are available. Why we have put this if condition is because this is also, this is not pruning, or this is not compression by sacrificing accuracy. This is lossless. So if the model is large and the bandwidth is not sufficient, the model has to be compressed efficiently, and whatever mechanism is available, so that should be agnostically deployed, so that the application developer does not need to worry much about. This should be abstracted. In case the application indicates the desire for suboptimal accuracy, the API should enable calculations for the necessary early exit strategies. because in many cases, the application, application may not want the desired level of accuracy that the original model provides. So in that case, resources can be saved or by ensuring that there can be an early exit point. That early exit can happen at the EV itself. So only up to the early exit point, the EV calculates, and there is no edge involvement, and the cloud decides that which point to early exit. Or this early exit can even happen at the edge also, so to save the edge resources. So so these are the requirements that we have mentioned, and these are the references. We have some literatures, recent literatures we have cited, and these are the two major standard contributions that we have found should be relevant to be discussed. That's all. Thank you.
Thank you. So I'll just open the floor for discussion. One second. So I see that Ricardo, you can start.
Yes. Thank you for the contribution. Very clear and good use case, at least in my view. I have one comment that may look editorial, but actually I think could be very relevant when you bring these requirements to working group 3 to define the enablers. I start with the editorial comment, then you will understand why in system perspective it may be helpful. Starting from page 3, when you start showing the workflow, you have a quite clear pictorial representation with some steps indicated with numbers. Then down in the description, you have the steps of the workflow in italics, and the numbers are different, so it's not so easy to match. And then you have a very good list of requirements. Of course, I would not comment one by one, but it's a solid list of requirements that again are difficult to map with the steps. Now, the suggestion for clarification would be to harmonize, right, the workflow with the numbering that you have in the picture, with the steps, and then with the requirements. I explain the reason. When even reading the requirements, sometimes it may not be immediate to understand which element of the system you are assuming will have to expose such APIs. Because in some cases it seems to be APIs that can be, let me see, referring to the picture, they may be relating to the constrained UE or to the mobile edge computing or to the cloud or to the SAF. Right? And that could be important because when you then move to the definition of the enablers, a set of API may be required at the device, another one can be in another component, right? And that from the reading was not immediate for me to get. That's the comment I would make.
I completely appreciate your comment, and this is really helpful. And we will address this in the next version. Thank you.
So any other comments on this contribution? Okay, Marco, you have the floor.
Thank you. And yeah, I agree fully with Ricardo on this mapping. There is another point that you use this terminology API as a title everywhere, but in the figure we don't see the API. So I'm wondering if, first of all, this requirement apply really to the API and where this is positioned in the picture. Thank you.
Yeah, so we'll try to create this even north, south, and eastbound APIs, and so east is for the edge, and north and south are from the cloud. We'll do that. We'll do that. Yeah.
Thanks.
Any other comments? So if there are no other comments, then this is a good contribution, and there's a good inputs also, discussion also. So now we move on to the next contribution. It is number 103. It is related to AI native digital twins. So the contributors can present their contribution now.
Hi everyone.
Okay.
From TSDSA and Tata Elxsi, we have put the contribution. Can someone share? Maybe I can run through with it. Or,
Okay. Okay.
if you can share the meeting link, I can also share. I don't have the meeting link with me, sorry.
Okay.
Yeah.
Thomas, will you be sharing or will I get the sharing right?
You can share.
Okay, I will share. Okay, fine. That is okay.
Hi everyone. Good morning, good afternoon, everyone. And myself, Jesu from TSDC and Tata Elxsi. This is our contribution on the AI native digital twin for cognitive network optimization management. So the use case presents the AI network architecture that uses digital twin as one of the core components to optimize and autonomously manage the telecom networks across the functional domain. So we have picked few functional domains for us to present how this will work and evolve. We have picked up energy efficiency, the predictive analytics, and the network slice management as the core domain context. Here, the AI pipelines are used to continuously build, train, deploy intelligent models. We have picked up time series forecasting, which is one of the core things in digital twin that we have been working internally as well. Anomaly detection for predictive analysis, and reinforcement learning, which learns from the digital twin. It kind of enhances its way to for further things, and which will interact with the digital twin simulation environment. So so the idea is to use two modes, which I've explained in the contribution also. There could be shadow mode, which the operator can use, or they can use for a closed loop. These models inform the closed loop decisions, the network configurations, and resource control. A dynamic knowledge base is also constructed from the historical data, state and actions, so that the model accuracy can be improved, as well as we can have explainability from the models. So the system operates both in shadow mode and autonomous mode to ensure that we can have auditable deployments, and applications such as autonomous change management and energy-based apps also integrate in the solution, so that we can have a complete AI native architecture that is aligned with our principles on AI native networks. So that's the abstract of what we wanted to give. Maybe I'll go to the diagram directly. So the diagram talks about the different sources the system will use, like network telemetry, events, service data, it could be traffic data, performance metrics, log data. Yeah, I'll just wait for it to come up. Ma'am, can we go a little bit down? Yeah, thank you. So then the digital twin engine creates a virtual representation of the network elements. It slices behavior. So there are different features in the twin that mimics the network. Could it be metadata, configuration, and others, as well as the behavior modeling is there. And we have an AML inference engine which builds up these models, like energy management models, idle detection, optimal configurations, anomaly detection models for predictive maintenance, and we also have the slice demand, the forecasting models for slice and demand prediction. And this feeds into the dashboard where the user can actually look at review alerts, and if they want, they can override as well. And a visualization for the digital, for the state and prediction and energy slices. And based on the learning data, there is a feedback loop mechanism which feeds back to the model so that it can retrain, or it can give some feedback back to the network elements to operate better. So this is the use case at a very high level. So the motivation here is to design something that is proactive, autonomous for these domain use cases, so that the AI native constructs can be used here. So the continuous training pipelines, which are powered by the MLOps and reinforcement learning agents, and we are able to build some dynamic knowledge bases. Today there's a static knowledge base. We want to build a dynamic knowledge base and real-time simulation environment, which is powered by the digital twin. What we see as the current, as per what we have observed, is we see these things operate in a very loosely in a reactive fashion, so that they cannot give that level of coordination, foresight, and the closed loop operation is still a little far away from us. So always they require a manual interpretation of KPIs. There is requirement for reactive configuration changes, which is error prone and time consuming. And existing systems don't have the capability to simulate outcomes in a sandbox before applying them. So we want to have a digital twin system that can simulate before applying to the real. So we know what will happen when that change is applied. So the AI native approach, what we're trying to give is the autonomous, intelligent, and context-aware networks. So this we are trying to align with the objective of the AINN, where we are able to like embed the our AI native pipelines in every phase of the network management. So it gives a complete closed loop operation and also powered by the digital twin based feedback loops. So overall impact of this approach to give better energy savings in the current infrastructure control, and we're able to give better QoS in the predictive traffic and slice management, and we're able to automate and have reduced operational overheads and enhance better system resilience in the telco networks. So this is the overall idea of the use case. We can scroll down to the use case scenarios, but this will be a format of what was already told only. We can go to the use case description, like the AI. So the use case involves the deployment of a digital twin enabled AI native system. I think we have also expanded on what all AI native is in here. One is the AI pipelines for network enhancements. So there is a AML layer which is responsible for orchestrating the model lifecycle activities like data collection, training, validation, deployment, and continuous learning. These pipelines control how digital twin interface with live network telemetry, like what will be taken, what is the learning, enable system to simulate and recommend some actions like energy saving actions or optimal size in real time. The AI models, what we are considering is the time series forecasting models like LSTM, GRU to predict real-time time series-based energy usage and traffic loads. Anomaly detection models for to detect any abnormal patterns in the performance where the KPIs are being used, and reinforcement learning for identifying the changes, configurations, and what parameter works well in the real load. So we can assume a parameter be set to be 2, then it works well, or it fails, then that learning is taken back to the system so that the simulation can be further improved, and we can prescribe a better configuration of parameter adjustments for scaling the network. So all these models are trained in a sandbox environment via the AI pipeline, which is validated through the digital twin, and it is promoted to a line inference stages only after the safety thresholds and accuracy are verified. And we also talking about the knowledge base where like it has a feature specific knowledge related to state actions, performance outcomes, and feedback loops. The policies that have been put in the networks, all these are queried and stored, queried by the AI pipeline digital twin so that the decision making can enhance. And as said previously also, we are trying to keep it as a live knowledge base so that there is an initial data set that is given to the knowledge base, but as the network learns itself, it will feedback to the digital twin and the AI pipeline so that it will be a living knowledge base. And we are also, in the use case, we are also proposing a specific application that can be built on top of it, like energy efficiency application, change management application, network slice applications, and anomaly triggering applications, which will help us to validate how this works. So these will be operated via the digital twin orchestration layer, and execute changes either could be on the shadow mode and or in the active mode. There are two modes that we are proposing in the use case itself. So this is the overall use case description. And the KPIs we have put, there could be energy savings, percentage energy savings, accuracy could be improved on prediction accuracy for traffic and load forecasting. We could have a match between a shadow mode and live mode operations, and latency would also be improved when it comes to closed loop configuration actions. And we are trying to address open issues around interoperability between AI pipelines, digital twins, and the existing network management systems, which are not yet standardized, and real-time network adaptation and lifelong learning for the, like the continuous learning for the AI agents. The explainability of the AI, because we are trying to give shadow mode and the autonomous mode, so we'll have better explainability of why that action was taken. And then the governance of the knowledge base, where it will be curated, validated, and evolved, maintaining the context of it, and we'll also make sure that it is scalable and it is generalizable so that it can be used across. So that is the open issues here, and we are putting the use case under the category of AI native telecom optimizations, and we've also given some references that we use to fine tune this use case actually. So that's about it. And we also referred the templates that were given the AFG ANN one, and to improve the submission as well. Thank you. Thank you so much for the opportunity.
Thank you for the presentation. So I see that Marco has raised his hand. So the floor is yours now.
Thank you, and thank you for the colleague from Tata for this interesting document. Obviously, digital twin play an important role in all these new advancement in terms of network. My comment is about if you can, obviously this is the first meeting where you introduce this topic. If you can elaborate in the future version in terms of distinguishing, for example, what are the telecom network assets and capabilities, and you say that this use case is about network optimization, then I saw in the use case you also have a sub-use case or maybe called as application of this general category of use case. But it would be interesting to distinguish between what are the capabilities on the network and what are the new capabilities that are classified as AI native, because here we are talking about AI native, not talking about in general AI and digital twin in general. So otherwise, when we see your picture, which obviously interesting picture at the beginning, is a sketch, which doesn't go in technical differentiation between components, data components. So we see basically a process where we see the role of this digital twin. But it would be interesting to say, well, these are the assets of the telecom network. These are the capabilities that can be used to improve the quality of this network optimization use case via functionality that can be provided by a digital twin framework, a digital twin system. So what are the AI native capability, and then how then this could be considered part of a digital twin system. Otherwise, we are depicting the whole architecture as a digital twin, and that's not the case. Digital twin is a solution to take into account, to mirror data, elaborate, then feedback, and so on. So it would be useful to distinguish from the telecom what we already have, and what are the new capabilities that could be plugged in terms of digital twin system functionality, and how these are AI native, because otherwise we have digital twins in general. What is the concept of AI native digital twin? All this is quite new, so I don't know if it's clear my point, but maybe I would appreciate your feedback now.
Sure, sir. Thanks so much for the feedback. We will also see if we can elaborate in the upcoming version. We will add these points. I think we took a stance to explain that how it is AI native, but I think we will identify the gaps. I think some of the gaps are already explained, but we will probably explain it in much more clearer way in the upcoming version, sir. We will do that. Thank you so much for the feedback.
Next, Ricardo.
Thank you for interesting document. I think I understood it approximately. I have only one concern, but obviously it's for VG2 chairs and vice chairs to assess my concern if it's valid or not. The issue that I see with the documents is that the part concerning the use case, strictly speaking, I summarize my way, it's included at the bottom of page 2, where you mention that what you need to do is autonomous slice orchestration considering traffic analytics for energy management. That's what you want to do. Then, main body of the document is actually a very interesting description of a solution, what you think you need to do that, which are enablers that may fit, in my view, may fit even with working group 3. So what I find a bit missing, actually, there is an excess of enablers and solution description in here, while I would find hard to extract the requirements that Raniana was suggesting before should go into the I-084. See my point? So this is a very good description of a solution, right? What I can't find are really, rather than your solution, the requirements that you would like to be documented in the deliverable of VG2. I don't know, but this is, again, my personal view, and it's definitely for Raniana and China Mobile colleague to assess if it makes sense.
Sure. I think when we started as a use case-based solution. That's why you'll see the faces of both use case and solution here. maybe we'll split the parts very clearly and put them as two different things, because here something on architecture is also there, because me
Correct,
being the background from architecture, maybe you'll see that that flavors of architecture also come in. We'll take this off, but keep only the use cases and the solution part of what it can bring into. We will take it to the another format of the the 96 document. We will.
Correct, you can do that. That will help actually.
Sure.
And that architecture part, you can also give it as input to working group 3.
Yes, yes, sure, sure.
So you can concentrate on the use case requirements in this document.
Yes, yes.
I see that Busi has raised her hand, so please take the floor.
Yes, just a small addition. So thank you for the contribution. The first of all, I think it's really interesting and touches a really important point. And you, as Ricardo also mentioned, you did also the VG3 contribution, kind of. But my small suggestion, if you want to, use this in the both in the VG2 and VG3, I think it needs to be some briefing. The thing that I'm trying to say is we are touching the time series forecasting, anomaly detection, and the slicing there, the digital twins. There are lots of concepts. In the use case, it's not easy to follow. So maybe when you revise the document, it will be more clear. But even in the architecture, maybe we can have a more compact version of it, because again, lots of concept, and all the concepts, I'm just thinking in an architectural perspective, they're bringing another box into the architecture. So there are different questions, so it needs to be investigated deeply. So if you can do it as well, it will be, I think, great for everyone, for us to digest easily. Thank you so much.
Sure, sure. Thank you. I will take that comment and we will work on it. Thanks.
Okay, thank you for the good contribution. One of the comments that we have received on the public chat, I'll just read it out. It's from Paul Harvey. So he has also said that he agrees with Marco's comments, and his suggestion is that to get some inspiration, there may be some ideas in ITUT Y.3061. So maybe you can look through that also. Okay. So now we move on to our last contribution. It is 104 number. It's about AINN networks, network slice marketplace. So I'd like the contributor to start their presentation, and they can also present their document.
Morning all. 1 minute, I'll just share my screen. Is that okay if you can share the document? Fine, yeah.
Okay, Thomas, please share the document. It's 104 number.
Yeah, morning all. I would like to present our use case proposal, AI native proactive network slice marketplace for dynamic service ecosystem. So as we step into 5G and 6G era, the telecom landscape is evolving rapidly. So enterprises now demand connectivity that's just not fast but tailored with specific latency, security, and reliability guarantees. So static networks no longer meet these demands. So this proposal introduces a dynamic AI native marketplace where enterprises can request custom network slices on demand with real-time SLA negotiation and assurance. So I think we can move to the introduction a little bit down. So yeah, still more down, like introduction part. So these are the terms that we have been used here, and down it's introduction. Yeah, like in this use case, we have been using the foundation models like Llama 2 to understand the user intent, then time series transformers like patch TST to forecast traffic loads, and LSTM autoencoders with clip VIT models to detect anomalies. This AI-driven approaches ensures that each slice is not only deployed optimally but also continuously monitored and adjusted to meet performance goals. So as I said, the architecture, there is an architecture down. Like you can go down to the architecture diagram. So here in the architecture diagram, you could see like there is a customer API where businesses send slice request with constraints like latency, bandwidth, etc. And there is a slice vendor registry which maintains the real-time access to available slice configuration from various operators. Then next is the AI agent, that is the heart of the system powered by LLM that processes the request, then scores vendor options and chooses the optimal slice that is based on the cost. So then SLA match and based on the historical performance as well. So then there is a slice orchestrator which provisions the slice across the RAN, transport and core domains. So and there is a feedback loop which ensures that performance is maintained through a closed loop control systems. So next would be the use case requirements. I think you can go still down. So here our use case requirements actually have given it as such, but it goes on like a data collection, data processing and data storage and processing, then the final ML output with the critical and expected requirements. So in the data collection, our critical requirement would be the user request, like we have to collect the user request. That is, for example, they need 10 milliseconds of latency and 99% of uptime. Then it is also critical to know what network providers is offering at that moment, their speed, their capacity or cost, etc. Then we need to collect the live performance data from every active slices. So also like from different vendors using common APIs. So what is to be expected from the data collection is like it should collect the past SLA success rates and pricing trends to make better decisions. And also we look for the patterns like traffic spikes or outages. So these are some of the expected requirements for the data collection. And for the data storage and processing, the critical would be it must store all the actions like who requested what or who is offering and what will be delivered. So all these are the critical thing to be expected, that is in the data storage and processing. And expected would be the cloud and edge system for flexibility. And next to the added value would be in the data storage and processing would be it should use a API based communication. So different parts of the systems can talk to each other easily. So also it should support for a live data streaming for fast alerts and updates. Next is the final thing like YAML output. So the AI must be allowed to negotiate or choose a vendor and start the slice automatically. So like it should able to change or fix the slice if something goes wrong. So also it should be smart enough to handle handovers. So again for ML, the expected would be it should explain what, for example, if it is in a plain language, so it should explain what it did in the plain language to users and regulator understands. So this is the expected, this is the user requirements. And yeah, then actually our platform also aligns with international standards. Like while our system is technically grounded in standards like 3GPP and GSMA, it also draws inspiration from real-world operator-collaborator models such as Free Move Alliance and Bridge Alliance. So these actually these alliances have shown how cross borders or multi-operator service management can be achieved at scale, particularly for enterprise mobility and unified SLAs. So also like our platform can extend those business coordination principles into the AI native domain, rather than focusing solely on static service bundling. We introduce a real-time intent-aware marketplace that supports dynamic slice discovery, selection, and monetization across multiple vendors, and with fulfill SLA assurance and regulatory alignments. Yeah. Uh, so our assumptions is like that the infrastructure supports cloud and AI native function, and the regulator permits like AI assisted SLA enforcement and monetizations. So privacy is ensured using federated learning and model fine tuning techniques that respect data boundaries. Yeah, this up to us. So thank you for the opportunity. Questions?
Thank you for the contribution. So any questions? Ricardo, please, you have the floor.
Yes, for fairness, the very same comment as before, right, for the other case. Actually, when you were describing the document, I noticed that you were properly stressing a list of requirements that I was noting down, like the collection of the user request, the knowledge of what the network can provide, the live performance from existing slices, the traffic statistics, and the SLA percentage. All these definitely are requirements that are very good. But then the document includes your own specific solution, which is maybe excellent for those requirements, but probably could fit better the VG3 enablers, right? That is the very same comment I gave before. There is another issue that anyway I would mention compared to before. Could you please, how can I say, highlight why in your view such requirements are calling for native AI concepts? Because my guess is that these solutions could be, also with the free move framework that you are mentioning, applicable to existing system without diverging from the current paradigm. So in your view, where is the need, the requirements that are hitting on the AI nativeness?
Uh, 1 minute. See, FreeMove Alliance is like a enterprise collaborator. They don't have a particular marketplace API like where the enterprises have to send their slices. So still now it is a static. There is no anything called as